which I try to encourage. Like, interrupt me today. This is a small group. So just interrupt me. Say, hey, hold on, Rick. Can you talk a little bit more about this? I have a question. Don't wait for me to pause and say, are there any questions? Because I will do that. I'm trained to do that. I'm not trained. I want you to interact, not just with me, but your question may be the same question that somebody else in the room has, right? So feel free to ask questions. My quick introduction of myself. My name's Rick Ayers. I've been with the CAT Lab, the Center for Advanced Transportation Technology Lab, for about 8 years now. Prior to the CAT Lab, I worked for Here Technologies. So you guys, some of the rich underlying probe speed data that you use here in the state of Georgia is from Here. I actually worked for that company for a couple of years. And then prior to that, I spent 20 years working for a small mapping company. Anybody ever heard of Esri? So I worked for Esri for 20 years. So I'm kind of a GIS geek at heart. That's kind of my passion. And I do a lot of GIS integration. Has anyone tried to do any GIS integration with the output from RITIS? Actually pretty easy to do. If you're interested in kind of integrating output of RITIS into, say, ArcGIS Online, I'd be happy to walk you through that. In fact, Matt and Sam, you know, the other Sam's not here. I think it'd be fun, if there's interest, just do like a dedicated virtual training session, like an hour and a half or something like that on GIS integration, if there's interest, right? And there's plenty of people that use Esri, because you guys have an enterprise license here in the state of Georgia, right? At GDOT?
I believe so.
Anybody know? Okay. Anyway. So that's a little background on me. My job for the CAT Lab is this sort of thing. I deliver all the professional development training on the RITIS platform all over the country. So I'm here in Georgia yesterday and today, and a couple of weeks I'm traveling up to Michigan, and then after that I'm going up to Arizona, and then so you guys are part of this broad community of RITIS users from all over the country that are receiving training. Some of the other things I do for the CAT Lab is I talk about technology and innovations within the mobility space and industry at industry conferences. So what are we going to cover today? Matt, I'm going to ask you to be my hall monitor on timing. You have an agenda, and the agenda, I forgot. I don't know if I didn't put that on that training website, did I? Today's agenda? No, I don't. I'm pretty certain I didn't. So today's agenda looks like this. Close that. Today's agenda looks a little like this, not a little. This should be the agenda. So so at 10:30, we're going to take a break for 30 minutes. This morning, we're going to cover, there's two primary sets of capabilities within RITIS, which is kind of the interesting differentiating piece of RITIS. We're going to focus this morning on all the real-time situational awareness capabilities of what goes in from a real-time perspective. What's that data? What are those layers? What's that real-time content that goes into RITIS that's then stored and archived that you can then query? You know, the things that we're going to cover late this morning, early this afternoon, are all about querying that rich set of data that goes into RITIS. So as my hall monitor, Matt, I want you to keep me tight on this schedule, because I don't know if you could tell, but I tend to ramble a little bit. And I get excited about this stuff. All right. Most of you are users, a couple of newbies, but we are going to go throughout the day, we're going to go through and dive into how to set up queries, some point later this morning after the real-time situational awareness capabilities. And then I'm not sure how the afternoon's going to unfold, late afternoon, but you guys have access to some trip-based OD data. It's called TRIPS data. It's from INRIX. It's a different connected vehicle data provider. And this trip data provides some pretty interesting insights for what routes vehicles took to get from one place to another based on your definition of, hey, I want to understand the pattern of trips in and out of this particular geofenced polygon, or through this geofenced polygon on this particular day or this particular time. So I crafted a scenario that helps with kind of you guys thinking about, from an ops perspective, thinking about how to perform after action analysis for special events in the Atlanta region. In this case, I ran some analysis on the Beyonce concert that was July 14th of last year. Actually, it was a 4-night event. And I ran my analysis on just one of those nights because here's the deal. Yesterday, we were talking about prepping for World Cup games, right? You guys are going to be part of that game plan, right? Is how do we think about not only keeping an eye on the network in real time, but how do we assess the impact on the network, where the choke points were, and what were the patterns of movement or routes that vehicles took in and out of Mercedes Stadium area. You have the data, you have the tools to ask those questions from surrogate events. And Beyonce concert is a surrogate event, right? It said that Beyonce concert is probably pretty close to volume, number of attendees, what you can expect at some of these 8 games, is that right? They are going to be here in Atlanta. So think about this, right? Here's the scenario from July of last year. I want to get my head around where those choke points were, where those routes are, what those routes were that were taken in and out of the stadium. Or Matt and I ran some analysis. We'll take a look at it late this afternoon, thinking about rideshare drop-offs. Okay, let me change my geofence, and then I'm going to ask the tools to just analyze where cars came into that polygon and then left that polygon, all within a time range of 5 to 9 o'clock. So we got some cool things lined up. I don't need to ask this question because I already have. I forgot that I peppered in some interactive quizzes, so this would be fun. So quick question, Slido, Menti. Who likes Slido? How many of you actually give presentations there's online surveys that you can integrate into PowerPoint? Slido is one of them, and Mentimeter is another one. Anybody use Menti? Yeah, all right, that was it. Okay, so more Menti. I'm starting to try out Menti. I don't want to talk too much about who we are at the Cat Lab, but really quickly to kind of establish, we're not some fly-by-the-night software firm. We were founded 25 years ago. There's 100 of us that work for the Cat Lab. It's a pretty substantial team of people, software developers, database engineers, UI designers, support team, data scientists. Got a really phenomenal team of data scientists that understand the underlying principles of mobility data. Pretty certain the ClearGuide team's not 100 though. So super team, we've been doing this a long time, and honestly have built one of the world's largest mobility data archives. Thing I like to always start with in talking about RITIS is this conceptual architecture diagram. So what is RITIS? What's it all about? It's a massive system. We're going to cover just kind of the surface, if you will, not even talk about all the tools. We're going to talk about some of the tools, but it's a massive software platform. And it's comprised of a lot of data that goes in. So all of these little icons at the top, this is all real-time data that goes into RITIS. One of the biggies for you guys is that connected and autonomous vehicle data. If you think about that in terms of speed data, that's a source, right? But we're also ingesting authoritative data from GDOT. Your ATMS system is called Navigator. We've got connectors to Navigator. So we're pulling in, every time an operator reports something, it's getting ingested. Your work zones are getting ingested. DMS signage information, that's getting ingested. CCTVs, we got a connection. There's also connections to national data sources like weather, National Weather Service. We're tying into the National Weather Service so that you can see in real time where there's precipitation and precipitation rate. But interestingly, and I'll talk about this, we're collecting and archiving precipitation rate for every single roadway in the country as precipitation moves across the nation. Crowdsourced data, see that icon on the far left? That's Waze. So we're pulling in crowdsourced Waze reported incidents for the entire country and archiving that. We'll talk about the event query tool later. All this rich event data that gets brought in, you can easily query it as well. If any of you do any custom development, like programmers? No? All right. Well, if you were a programmer, we have APIs for either the real-time or analytics part. What we try to do with RITIS, there's all this crazy amount of data that goes in. It's coming from all these different data sources. We fuse it, we normalize it, we archive it, and then down at the bottom of that conceptual architecture diagram, you see all these decision support tools and solutions that are designed to make it easy for you to query the data. That's the whole point is, I don't want to write a custom code. I don't want to, dump all this data into Tableau and spin these cubes and try to get something out of it that I need. We try to build some simplified user interfaces that can help you easily query the data and pull out what you need. I like showing this to just show you you're not alone. You guys are one of nearly every state in the country that's using RITIS. I mean, it's a pretty massive footprint, right? Nearly every state DOT in the country is using RITIS in some capacity or another. And in the Midwest, you know why they don't use it? They don't even use ClearGuide. You know what there's nobody out there. But kidding aside, there are several rural states, like Vermont's a pretty rural state, right? Anybody been to Vermont? Beautiful state. I mean, stunningly, it's absolutely gorgeous up there, but it's rural, right? And for years they said, well, why do we need RITIS and probe data? Because we don't have any congestion in Vermont. Well, that's the reason why you want probe data and RITIS, is because you don't have congestion. You don't have the ITS devices. Probe speed data can provide insights to where you have issues on the roadways. You may not have cameras. It's going to show you where there might be a problem set due to a severe weather event that heretofore they didn't have insights to. So from an operations and now planning perspective, they're seeing that the combination of probe speed data along with Waze reported events, because they don't have a real solid ATMS in Vermont, that it's providing some really terrific insights. I'm not going to talk about...
Just to add on to this, I like ClearGuide. I like ClearGuide plenty. That said, I regularly do use it too. Because there are certain things that I like ClearGuide better than RITIS. That said, nearly every tool that is built in RITIS has gotten the official blessing and probably paid for by the federal government in some form or fashion. Meaning, right, so like when you're looking at travel time reliability and the metrics and the formulas that went on behind the scenes to make that work, US DOT paid for that, which means that when you're doing reports up and down the line, it has gotten their blessing and they know that the math is good.
The math is solid. Yeah.
And Rick will go into this later on, but there's some really awesome tools in here for emissions impacts and energy impacts. And that all got paid for by the Department of Energy and got their blessing. So if you are doing CMAQ projects, that follows the EPA moves model as it's supposed to, on and on and on.
Yeah, and the updated moves model.
So like I said, just sharing that you get blessings from on high from a lot of people.
By the way, if you're interested in exploring, that's an app. And in your PDF copy, you could click that app link and you can interact with the map. It'll show you what data states are using or what tools. And to Matt's point, a lot of these states are using are licensing the federal probe speed data set and tools. It's called NPM RDS, National Performance Management Research Data Set. In fact, you guys have access to that, right? And I'll talk about that a little bit. All right, time for a quiz because I do want to talk about this a little bit. So go ahead and scan the QR code or navigate open up a new tab in your browser and navigate to slido.com and enter 6163298. And what is connected vehicle probe data? Oh, that's a live leaderboard ranking the fastest drivers on every highway in Georgia. It's a secret government program that tracks how fast you're going to decide when to change traffic lights. All you SIGOPS people. Or no, it's real-time speeds on road segments derived from GPS pings collected from vehicles and devices. I like the fact that we have people with a sense of humor in here. I'm sure Matt is one of those yahoos that's answering the secret government program. All right, most of you have answered. So you're right. Connected vehicle probe data is derived from a number of different sources. So here Technologies, they have a boatload of companies that they partner with, and those companies give them anonymized real-time GPS pings off of their vehicles, like Mercedes, Volkswagen, Audi, Porsche is a big customer there. BMW for here is a big partner of theirs. So, because here's corporate is in Germany, so VW, Porsche, Audi, BMW, Mercedes, plus a bunch of other partners through LBS, location-based services partnerships that they have. I mean, boatloads of data is being sourced by here through all of these partner relationships, including fleets, any delivery vehicles, freight trucks. They're bringing that all together. They're doing their own kind of what I call wizardry, black box stuff. Take a look at this diagram. This is some wacky stuff that here and Inrix and TomTom do on the fly. They're taking all this real-time data on the left that's basically just GPS ping points off of vehicles. They're running it through their engine, and then they're in real time mapping it to road segments and then doing a harmonic mean. If you're familiar with that term, it's basically an average of speeds based on the length of the road segment. So you guys have a couple of different types of data available to you. Road segment, underlying road segment databases available to you. You have a TMC segment database and a TS segment database. I don't remember if I spent a lot of time on this in the deck, but the road segments that these speeds get mapped to in For TMCs, those road segments are generally longer. Not real good fidelity, spatial granularity fidelity for signal operations analysis. But the TS data, TS stands for topological subsegments, the length of those road segments are smaller. So if you're doing signalized corridor analysis, always use TS data, okay? That's kind of the rule of thumb. Signalized corridor, when you're setting up a query, first thing you got to do is define the road, the data source. Okay, it's going to be here. And then, well, what do you want? Do you want TMCs or TS? If you're doing signalized corridor analysis, you always want to use TS because it's going to give you that finer granularity. It's just meaning that they're doing their harmonic mean calculations to smaller segments of roadway, which is good for you guys. All right. For TSM&O operations, and you guys keeping a close eye on what's happening during the World Cup, you're going to need some. It's nice to know that you don't have to have a navigator login to actually see what's going on. You can set up RITIS. I'm going to show you a few things. You can set up RITIS traffic map to be your own ATMS. Like, you configure the layers you want. You could create your own CCTV video wall, and you could filter out the events and incidents that you want on your map and not what everybody else sees. The real-time situational capabilities of RITIS, it's called traffic map, and we'll dive into traffic map. It's yours. Every single one of you have your own unique login. When you configure that map, it's your configuration. So the next time you log in, all those settings are there for you. And that's how I want you to think about some of these real-time capabilities, is that it's your own kind of medium weight ATMS, but it's also important to kind of think about, and we'll walk through this, that take a look at the call outs here, 1, 2, and 3. Every bit of real-time data that you're going to see when we jump in together to traffic map, every bit of that, number one. Number two, we're actually capturing a lot of rich attribution for all of those events, all of that data that's coming in, whether it's probe data or weather data or authoritative event data from GDOT. All that rich attribution is that you see in real time, and more is coming in. But number three, we're archiving it. Matt reminded me yesterday, we have an archive that goes back to 2017 for the state of Georgia. Every bit of probe data for every road in the state of Georgia, every incident that's ever been recorded in the state of Georgia, we've got an archive and tools for you to immediately access it. Matt made the joke. He said, yeah, I don't have to go pull a spool of tape off a shelf for 2018 to see if I can get that event data. It's there. The tools are there, the archive's there. We have 2 rows in a data center in Maryland. It's a gigantic data center. It's probably got 50 rows of racks in it. 2 of those rows are dedicated to RITIS. I mean, it's a massive, massive infrastructure. We've got a whole team of IT people maintaining all this crap. It's nuts. The other kind of cool thing about RITIS, traffic map, RITIS in general, though, is that it's this common operational view across not just your organization, but for agency partners. You guys are going to be working closely with ARC and others in support of World Cup. They all have access to the same view. So if you're thinking about collaboration and cooperation and coordination, this common operational picture that we're going to walk through together, it's available and is probably used extensively through many of your agency partners. If you're working with an agency partner and they go, "What's RITIS?" You go, "Oh, well, just sign up, request an account. You have access to an account. If you got any questions, send an email to support@ritis.org." I mean, it's a pretty straightforward process. If you're working with a partner or consultant, like AECom, we've got a tremendous presence here yesterday and today. These guys already have what's called a data use agreement in place to use the data, and the platform just comes for free. Like we at the Cat Lab, we don't care who uses RITIS. Who cares about access are the data providers, right? So you got to sign a data use agreement. All right, here's a quick demo of some of the capabilities, layers and so forth that are within Traffic Map. We're going to work with Traffic Map Beta today, real-time traffic. Everything is interactive on the map, such that if you turn on a layer, you want to ask questions about that particular layer, whether it's speed data, weather alerts, national weather alerts, as you saw, weather radar, and road weather data. I'm going to talk about road weather data in a little bit. We map all sorts of stuff for different agencies. This is evacuation support information, freeway incident traffic management plans as well. If you have the data, we'll map it. These are emergency frequency and communications. Those are fun. I'll demo that to you really quickly. Transit data. So most of transit networks in most urban areas have been kind of mapped out. In some cities and urban areas, we're connecting, like in this example, to real-time transit bus, trolley, train location information. Real-time CCTV feeds throughout many of the states that are users of RITIS. You've got streaming video plus some still images. DMS message signs, dynamic, real-time, all of that's being archived as well. Some of this we'll cover in real time here in a little bit. Event data. Again, we're pulling in event data, not only from Navigator, but from crowdsourced content from Waze as well for the entire country. I'll pinpoint how to differentiate between your events and Waze events. A little bit work zone data. If you're working on projects in and around work zones, important to have that content and some specialized reporting that I'll talk about in a minute. This is something that in this demo, you guys don't have access to, but it's part of my demo. This is dash cam imagery off of freight trucks. It's a specialized data source. It's actually pretty damn cool. And it's real time. We archive it and integrate it into some of our analytics tools.
For the dash cam images, is that strictly from the commercial vehicles?
Yeah.
Okay.
Yeah, just freight trucks. Yeah, most
If Rick is selling you on something that we don't have.
that you don't have access to. Yeah. It's a good question, but yeah, a lot of telematics company or a lot of freight trucks companies, most freight truck companies have to have telematics systems on board to record safety telematics, performance telematics, and hours, right, that they're on the road. Part of those systems, not only just the underlying telematics, but road-facing or forward-facing dash cams, and they're collecting snapshots every couple of seconds. And we've got some sample data that connects to that.
Does the data tell you when there's a flood?
Pardon?
If there is a flood, can it tell you?
So what was your name again?
Melvin.
So Melvin asked, hey, if there's a flood, Rick, will RITIS tell you if there's a flood? It's a great question and an excellent segue to what we're going to walk through in Traffic Map. So I'm just going to mention this slide. And I don't want to spend any time on it when we're walking through traffic map together, but there's a separate module within RITIS that allows you to configure your own video wall. Super useful. While in traffic map, you could click on CCTV feeds and create a pop-up window of an organized set of CCTV feeds. There's a separate module that lets you like predefine which CCTV feeds you want on your video wall. And I've seen a lot of RITIS users, they'll have maybe 2 monitors. One of the monitors, they'll have, oh, here are my 8 cameras for my, like you're in SIGOPS, but you're dedicated to West, Central, or East. So keep an eye on things for your respective district or geography. It's a great tool. I just don't spend any time on it. All right, you guys ready to dive into open up traffic map and RITIS? Let's do some exploration together. If you will, go ahead and fire up, open up a new tab in your browser and navigate to ritis.org. And when you navigate to ritis.org, it's going to take you to what? The incident list, right? Why is it taking me to the incident list? I do not know, and I will never know, but it is what it is. So just quick, most of you are RITIS users, you're familiar with the fact that by default, when you fire up RITIS, you 2 young men over here, it's going to take you to this, see how it's tabbed at the top? Transportation system status, data archive, personal traffic alerts, administrative tools. I have administrative tools, you do not. So don't tick me off in class because I'll shut you down with my administrative tools. Ask good questions, not bad questions. So the transportation system status tab, again, remember I was saying there's 2 primary sets of capabilities within RITIS. There's the real-time stuff and then all the analytics against the archive. Well, the real-time stuff is all underneath that transportation system status tab. That's kind of a way to think about it. And then the tab next to it, the data archive tab. Oh, that's the archive tools that I have access to. All right, I'm going to walk you through a couple of things that I think would be useful for just configuring RITIS. If you've not configured traffic map in the past or just RITIS in general, in the upper right-hand corner, there's a settings button. One of the things that I always like to point to folks is, like when you open traffic map, it's great to have it always open to the area of interest that you want it. This is how you do that. You click that settings tab, you click the map preferences button, and then you go in and define, okay, I want it centered on Fulton County, Georgia, and zoom level 7. And when you set that, anytime you go to traffic map, it's going to automatically zoom to that particular location at the scale that you define. All right, so that's one thing to keep in mind. The other one is incidents. By default, I honestly don't know if what you guys get. Has anyone not configured the incidents from a filtering perspective? Doesn't look like you have. No, go back. It's your browser. Okay, so this gentleman has 41,317 events in his event list. Notice how I only have, events or incidents. I only have 5. Rick, why do you only have 5 and I have 41,000? Because he hasn't set up his filters. So let's walk through how to filter. This is your filter, right? Like, I don't want to see all this other crap. I just want to see certain things. So one of the things you could do is you could define like what incidents you want to see from a geographic perspective by clicking that region of interest button. And then you could just draw a box or draw a circle like around the area that you're interested in. And see, notice now I have 11 incidents because I expanded my geographic reach of incidents. The other thing you can do to filter down that incident list further is click this button here in the upper right. It's the filters button. I zoomed out to that filters button. And now you can do all sorts of fun things to clear out events that you really don't want to have to pay attention to. Maybe you're not interested in work zones. So in my case, I said, you know what? I want incident type that's not equal to road work, right? So now I'm not going to see any work zones in my incident list, and I'm not going to see any work zones in the traffic map. The other thing is, maybe you don't want to see Waze data, or maybe you only want to see Waze data. So you say, okay, data source is equal to Waze. You click done, and now notice in my source column, it's only Waze reported events. And I have 201 versus what's Navigator reporting within the same geographic area. So we have 201 from Waze, and Navigator has 11. You know, that kind of talks to that notion that, you know what, 511, 911, safety service patrols, state troopers, CCTV cameras, they can't be everywhere. And, you know, if you want insights to events and things that are happening on the roadway, it might be interesting to have Waze up, right? So play around with it. You know how to filter it out or filter it in if you want. But once you've done that and you go over to traffic map, that's what you're going to get. All right, so go ahead and click the link to the traffic map beta, and let's explore traffic map a little bit together. In the upper right-hand corner, the first thing I want to point out is that if you're in a dark room, there's a dark mode and a light mode toggle that you can enable. It's kind of useful. I'm kind of a dark mode kind of guy. I like the dark mode. In the lower left corner, there's two different base maps. You got a road base map. I'll turn it back to light. A road base map that is just a light gray road map, or you have a satellite image, satellite aerial image. It's all coming from OpenStreetMap. So you have a couple of different base maps to choose from, depending on what you're interested in seeing as your base map. There is a expandable legend. So if you want to, like, what does that symbol represent on the map? Just click that legend and it'll tell you what the different symbols mean. Okay. Now then, the important stuff. I'm going to zoom my browser back out so I'm not so zoomed in. Let's explore the different layers that you have available to you through Traffic Map Beta. Is this static, what I'm seeing? No. Remember, this is all real time. This is like, again, this is your own ATMS that you're configuring. When you expand the layers list in the upper right-hand corner, it exposes, you know, I have more layers than you probably. Well, I know I do. But this layer list is what's available to you to turn on and configure, if you'd like, within Traffic Map. Notice that some of the layers have this light gray or light black thin box around them. What that means is that if you click and hold that layer, you could drag it to a different order within the map. So you could kind of move those layers around within the map. Everything down below that doesn't have a little box around it, you cannot move. All right? Because it's basically a tiled cached vector map that you cannot order. Just from an exploration perspective, let's go ahead and first start with, I'm going to turn this stuff off. I'm going to go ahead and turn on probe speed data. Now then, when you look at Google Traffic Map at a regional scale like this, what does Google Traffic Map look like? Probably looks like this, right? This is raw speed. Most consumer traffic apps, they're only mapping raw speed for you. You're pulling in some cool data from Here Technologies, and there's several different ways to map speed. You can map raw speed, or because you're a smart person that works for GDOT, you know that that's not meaningful in the city of Atlanta because there's a lot of slow speeds a lot of the time. So you're going to go ahead and click that little black arrow to the left of probe speed data. It expands. It allows you to turn on or off different probe data providers. Do all of you have all three? No? Yes? Okay. Which one do you have? Just here?
Here and Hendrix.
Okay, here and okay, those are important. Yeah, those are the important ones. So here and INRIX speed layers are probably going to look the same, right? Their sources are different, but it's probably going to look the same. But go ahead and click the gray arrow to the left of here now to further configure how you want to see that real-time probe speed data. Now then, right now, I'm looking at, right now I'm looking at speed. You can look at congestion, like where's it congested? Where are things backed up? My favorite, and I think it tells a better story, quite honestly, is comparative speed. Because what that's doing is that's looking at the current speed for that segment of road for that time of the day relative to historic conditions. So it's kind of like visually, it's a better indicator of where there's general issues relative to historic norms for this time of the day, this day of the week, this week of the year. And then if you want to declutter the map even further, notice how there's this little radio button, only lowest values. Click that on, and now you have, just the lowest, just the outliers, basically. Huh. I'm not sure why the greens are popping up there. If you want to explore the speeds themselves, or these roadway segments, and say, oh, well, what is the speed at this particular roadway? Just zoom in, double click on the roadway segment. You know what? You need INRIX on. And when you double click on a roadway segment, you get a real-time speed profile for that segment of roadway. That's kind of a cool feature, right? Like you can interrogate individual roadway segments to get the speed and how it's changed over the last several hours. That's what that speed profile does. And we're capturing and archiving all of that for you. And it's showing you trends. You can zoom to the segment. Maybe you wanted to do some analysis on that particular roadway segment. I guess you could copy that ID. and then throw that into probe data analytics. All right, so Melvin, we're going to get back to your question. Like, you thought I forgot about you, didn't you? All right, so I'm going to reconfigure this back. I'm going to zoom out a little bit. Go ahead and turn on the weather radar, which is right below probe speed data. Go ahead and zoom out until you find some weather. This is the weather radar is from National Weather Service, NextRad Weather. There's some thunderstorms here in Louisiana. Go ahead and zoom over to Louisiana, if you will. For the moment, turn off probe speed. Okay. Now turn on the road weather data layer, which is just above probe speed. Do you see anything turn on?
You just have weather. Yeah, weather and probe. Weather
We have
radar.
road weather stations.
You guys don't have the road weather data layer? God bless America.
Yeah, we have road weather stations, that's it.
Weather radar.
Weather radar,
All right.
road weather stations.
Can someone please turn on road weather data layer for GDOT? Period. Immediately, please. All right. I'm going to fix that for you, okay? Hang tight. What you will see eventually. Oh, that's interesting. Why is that red? What you will see eventually is another data layer. And, oh, man. There we go. All right. Something wonky was going on. I think it was my internet connection. I'm running off MiFi, but all right. We see weather. This is coming from the National Weather Service, Melvin, right? So NextRad weather radar, where it's red, it's raining like a son of a gun. Where it's yellow, it's raining pretty hard. Where it's green, maybe it's just drizzling or whatever. Every single pixel in the NextRad weather radar service is collecting precipitation rate. So what we've done, and this is kind of a differentiator from a clear guide perspective. I don't think anyone's doing this. We've been doing it for a couple of years. As the weather radar NextRad is passing over the nation, every 2 minutes we are conflating the precipitation rate to every single roadway segment that is underneath that rainfall. So if imagine spatially, here's all the rainfall onto a roadway. If it's raining at 0.25 inches this 2 minutes, we're gonna calculate for that 2 minutes for that roadway segment that it's getting 0.25 inches. If the center of the thunderstorm moves over that same segment 2 minutes later, and it's raining at 1.5 inches per minute, boom, it's going to capture that. So we are in real time. We are calculating precipitation rate for every single road segment in the country, which is absolutely nuts. So when you turn on that layer, in theory, well, you saw it a minute ago. When you turn that layer on, it's just a visual representation of where we've captured precipitation. and the color coding on the road segments generally corresponds to the precipitation rate. Why is that important? Well, when we dive into the analytics stuff later today, later this morning, and early this afternoon, there are several tools that are taking that precipitation rate and capturing it on the analytics side. It's crazy cool. Like the congestion scan captures precipitation rate. The trend map will capture precipitation throughout the period of time. There it is, it came up. So if you run a congestion scan for this corridor, you'll see higher density hash pattern over that segment versus, these other segments. So very, very distinctive, cool feature to be able to capture weather, precipitation rate, and it's not just rain. It could be hail, it could be snow. We've got users out in the West. They've captured dust storms on through weather radar. So it's a very, very, very cool feature. All right, so that's what road weather late data will look like. If you would go ahead and refresh your browser. Let's see if anybody's paying attention to that message. Nothing yet? All right. Well, periodically check that out. All right. So, Belvin, does that answer your question?
Yes.
Awesome. All right. So that's road weather layer. Weather alerts also coming from the National Weather Service. Whenever you've got your weather app open and you get an alert for your zip code, let's say it's
We don't have that one either.
We don't have that either.
We only have road speed data and weather
We have
radar.
weather radar. And road weather stations.
Well, I'm glad we're doing this. We're finding things that should be turned on that aren't turned on. All right. As we move up, I'm kind of curious. Turn on the. Okay, before I get into it, how many of you are concerned at all with public transit in context to your work here in the room? One, two of you? All right. I'm going to pass over that. Sorry. Know that you have access to some degree to public transit.
We do care for these big events, right?
What's that?
We do care for these kind of events. Day to day, it might, yeah, normal day, maybe not. World Cup, yes.
It,
So, like, very weak would be helpful.
it does not, well, here, hold on a minute. Do you guys have the public transportation layer?
Yes. And yeah.
There is no data for extra event.
Hey Rick, email me a screenshot of
You have it.
right now.
I had it, it shows up Brooklyn for Atlanta.
I gotta remember how.
Line, we go line, and then lines. And all the bus routes. Over the BRT,
I'm gonna just do all.
right here. No, I'm looking at.
Sorry.
Oh, right here.
Does this look like your transit network?
Yeah.
All right.
And buses, yeah.
Now, Justin, what we are apparently not doing for ARC, this region, while we've mapped the transit network, and it looks like the networks in the map, what we're not doing is connecting to the real-time feed, like the GTFS feed, if that might be, whatever the transit system is supporting. So like if you zoom into DC region, all these little black dots, those are real-time locations of buses or metro trains.
Are we supposed to have access to the stops option on the filters?
For a transit, no. So the stops are only going to be mapped if we're pulling in your GTFS. But I'm showing this, and Justin made the point. I'm showing this because you could have this, right? If you said, "Hey, ARC, we'd really like to see your feed of real-time transit and bus locations in RITIS. Can you work with the RITIS team to make that happen?" We will do that at no additional cost. I wouldn't be in time for World Cup. Yeah, but I mean, if there's a critical layer that you really wanted to see, like this, because you guys have a subway, like a light rail, right?
Well, we have Marty, yeah, and then we saw the line there too of the streetcar. You can see down there as well.
Okay, so there's streetcars and more. So maybe those are two separate systems. Are they still?
Heavy rail has bus routes and it has that streetcar system.
Okay, so the streetcar is your light rail. Okay. I mean, it's worth an offline conversation.
Yeah, I mean, I think we kind of rely on market to manage those schedules, and they might look at it a bit with the city and even Georgia World Congress Center, Mercedes-Benz, but it is interesting that we don't have any insight to their.
It would be cool, right? It'd be really valuable to know where their, not just where their facilities are, but where their assets at any given time. So, Sam and Justin, for you both, I think it's a worthy, take note. Let's have a follow-up conversation about that. Sure. Okay. All right. Moving on and up the layer list. I'm just going to touch on a couple of these things. Dynamic message signs. They are what they say they are. These are all live in real time. So if you click on any of your DMS messages, it'll give you what's being messaged or what's being gathered at that moment. Traffic detectors, you do have a network of speed and volume sensors throughout the state. I'm not that familiar with this aspect of traffic map, but I think that's just, actually it's a pretty comprehensive network of sensors.
So with the traffic detectors, does that just give us vehicular traffic, or can we get additional traffic as well?
So that should be, these triangles should be green or red, like this. Has anyone used this layer before in the state? I know it has worked in the past. Yeah. All right, moving on. Road weather stations, you should have that one. This is Federal Highway Administration's road weather national network. And if you click on any one of those symbols, it's going to give you the RWIZ info for that road weather station, which is kind of cool. And then the last layer I want to explore with you is the incidents. So I'm going to turn everything else off. Remember, I have filtered out work zones, but I'm going to bring those back in for demonstration purposes. Again, all of your incident data is coming from Navigator, and all of it's interactive. So this is disabled vehicle. If you click on any of these events, it's going to give you some basic details about the event in the pop-up, like if there's lane closures, when the event started, when it ended, or last updated. Some of these events are a little richer in detail. Icy conditions, what? That can't be right. It's never icy in Georgia. No, I'm teasing. What are these stars? What is that? Special event reported by GDOT. Work zones, you can explore those. There is a separate, I'm not going to spend any time on it. If you're interested in spending any time on work zones, there's a work zone performance monitoring app. It's called WZPMA. I encourage you, if you're at all interested in work zones, check out WZPMA. All of your work zones are organized by county within the WZPMA app, and consequently, you can explore individual work zones within a county and get a detailed profile of those individual work zones.
And is it pulling in any of the like TIR construction information from Navigator?
That's a good question.
What was your question?
If it's pulling in any like TIR information from Navigator, so you can see like when it's scheduled or if they called in or anything like that.
Well, probably not that level of detail. So let's go into Fulton County. That's the county we're in, right? Fulton, Jiminy Christmas. You guys got some. That's Franklin. 17,000 work zones. Oh my God. All right, so let's open this one up. This one's got a bit of a queue building. Should be interesting. So when you click on an individual work zone within the monitoring app, dashboard app, it will open the profile for that specific work zone. So in the upper left, you see, okay, that's the I-85 work zone. There's some configuration options for what you want to see within the roadway diagram. The queue that I talked about is represented in blue with the head as the dot and the queue building upstream what looks to be, if the whole segment, so if the work zone is in the orange, notice that there's a mile indicator, 5.6, that indicates the number of miles upstream from the work zone. All right? So if I were to guess, the length of that queue is probably just almost 2 miles, because it starts ahead of the work zone and it extends upstream what appears to be about 1.5 miles or something like that. In the lower right-hand corner is your user delay costs table. So that's nice. It's giving you this, it's calculating the impact of delay per vehicle miles traveled or per passenger vehicle and freight truck. You could change this to, okay, all right, I want to see what total delay is or vehicle miles traveled within that work zone. So some great stats And then we'll cover some other cool tools that we have for performance measure reporting later. But I haven't heard any questions. Got a question. All right.
Are your traffic cameras working? Because I know with the transition over to iNet, we've had some issues with like camera streams and.
Yeah, we were experiencing some issues yesterday with the streaming images.
Yeah.
So the snapshots show up, but not the stream. And I think that's an issue across the state.
Because when they moved over to the iNet, I guess Skyline involved, yeah. There's some issues with the streaming. Yeah.
All right, so this young lady's question was, for the CCTV camera feeds, are you guys experiencing the same problem that we are with the streaming video? Like you could click on these icons or symbols and pop up like a snapshot of the CCTV feed for that moment. But if you click it to try to get the stream, you're going to get this nonsense.
We've been going through a lot of ATMS updates. It's not surprising. And
Yeah.
Matt's also been pointing our IT to your support team, and we'll keep them in mind, but it's just not. Unfortunately, getting this ready for World Cup is probably not our priority at the moment, but
No.
it's noted and we're going to keep pressing.
It's a broader issue that will get resolved eventually, but for now, know that you at least have a snapshot, but the live stream, that'll be up and running
So every camera
soon.
can have a snapshot option?
Generally.
Like I said, it's real, what the services we're paying for here, we're really trying to. This should be fully functional as Navigator is. There's no reason it shouldn't be. So if I don't know, in a few months it's still not active, that's just on us not providing RITIS the data they need, the connections they need. So you can reach out directly to me if you want to remind me about it.
Thank you, Justin.
This feature is better.
Yeah, we do, and we want it working for you, right? All right. Any other questions about traffic map beta? Why is there 2 traffic maps? Why am I focusing on traffic map beta instead of traffic map? We've re-engineered some of the mapping engines on the back end, and we're using more vector tiles, if that makes sense. So it's a little bit more performant than the old traffic map. So we're just migrating features and functionality over to traffic map beta. And eventually, traffic map will go away. The name traffic map beta will not have beta at the end of it. There'll just be one traffic map. Okay? All right. Any questions before we take a break? No? There's one more piece, sort of real time, sort of archive-ish. Go over to Data Archive really quickly. I'm going to jump ahead, and I just want to spend a couple of minutes on this. Go to Data Archive. Go ahead and open Probe Data Analytics. And in the upper left-hand corner, click Region Explorer. Now, so go from RITIS landing page at the top. Remember, there's several different tabs. Go to Data Archive, and then click Probe Data Analytics. Once you have Probe Data Analytics open, click Region Explorer. Okay, you got it, you got it, you got it, you got it. All right, you all got it. What is Region Explorer? This kind of looks like traffic map, Rick. Oh, but it's not. Very, very cool very distinctive sets of capabilities in this real-time map that provides historic context. Anybody know what that blue mess is all over Atlanta? A bunch of blue dots, blue lines. Bottlenecks. They are queues. Where can you go on any map to actually see where there are choke points on your network in real time? Region Explorer is a real-time view of not just traffic, congestion, and speeds, but it's also a real-time view of where your choke points are and where your bottlenecks and queues are located. As you zoom in, notice what happens to the list of queues or bottlenecks on the left. They shrink. So it's all map-based. Yes, question.
Is there, so mine, I think is showing something different.
Because it's,
Data.
as you zoom in and zoom out, you're gonna get, wherever you are, you're gonna get a different list of bottlenecks and a different list of events that are within that map extent.
Okay, so I'm getting like, I'm seeing all the bottlenecks, and it looks like it might be like the construction icon.
Yeah.
Instead of the dots.
Yeah, that's what I'm.
Yeah, that's fine. You just gotta, so there's no bottlenecks where you zoomed into.
Okay.
Then they
So,
have in-rigs.
you may have to check.
Oh, there we go.
I mean, here.
So, all right, so that's in the upper right-hand corner under display options. Click that button. You guys need to have here turned on. So that was the problem. Look at that, technical support right here. Yeah, now we're cooking with gas. Yeah, because here's your probe data provider, right? Now, if you zoom out to the whole state, or nearly to the whole state, watch what happens when you change it back to INRIX. You'll see all of your neighbors. Yeah, we see North Carolina, Tennessee. Actually, Florida's a here customer as well. But all right, really quickly, lots of controls for what you show in the table, on the map, and the different speed layers to have in the background for Region Explorer. Real quick orientation, this list of bottlenecks and queues on the left, the length of the segment and the bar corresponds to the length of the bottleneck. The color corresponds to the duration of the bottleneck. How long has it been active? Okay, so if it's light green or whatever this color is, it's not been around very long, like 45 minutes to an hour, something like that. You also have filter capabilities. So in the lower left corner of the map frame, click filters, click bottleneck length. And maybe you don't want to see all the bottlenecks. Maybe you just want to see the bottlenecks that are greater than a mile in length. That kind of cleans the map display up a little bit. And no surprise, wherever we're seeing congestion, we also see some very short bottlenecks. Why is that one? Huh. That's weird. Now then, this one's really important. As SIGOps guys, you want to go back and investigate. Maybe you got a complaint about signal timing, or there's some issue with corridor. Is this some old lady just bitching about her not being able to get to the grocery store or medical appointment on time, go into time selection, click that. And if you want to look at bottlenecks for a specific point in time, click previous point in time, change the date. Let's go back to whenever, go back to a specific date and time. And I'm going to look at that Beyonce concert at 9 o'clock, 8 o'clock. And now I can see where all the queues, bottlenecks were, no surprise, on the night of the concert at 9 o'clock at night. So it's a great way to go back and do some investigative work and kind of hone in and look at and explore in particular where a choke point may have been during a particular time, and if it validates some complaints that might have come in. Or you want to just, we have a separate bottleneck ranking analysis tool that's super useful for looking at all the bottlenecks that develop for a particular day or range of dates. We'll talk about that a little bit later. But if you wanted to really dive in, explore specific time periods, this is a great tool to do that. Any of you used Region Explorer before? All right, so this is new. You learned something new today, Region Explorer. All right, let's take a break. Come back at 11 o'clock. If you have any questions, obviously I'm not going anywhere.
Is it a comparison to free flow speed? Is it a comparison to typical speed?
The bottleneck calculation, there's a federal highway formula that's generally accepted, and that formula, I'm actually gonna graph it out because we're on a break right now. Was Kyle?
Yes.
Let's see if I remember how to graph this.
It'll be a long suffering. All right, Kyle, does this graph represents the trigger definitions for when a segment of roadway falls into a bottleneck or queued state. Every probe speed data provider
they update their core map that speeds are mapped to on a quarterly basis. Along with that map update, they update free flow speed on those segments.
That's done quarterly?
Generally quarterly for here, INRIX. You'd have to ask Matt to get the details about here technologies, but generally speaking, it's quarterly. They update free flow speed. So we have whether it's rolling quarterly or rolling annual based on, quarterly, I don't know the details, but generally it's a pretty fresh representation of what free flow speed is. If the speed at any given time for that time of the day, that day of the week, falls below 60% of free flow speed for more than 10 minutes, boop, it automatically triggers that it's in a queued state. So, this is, that's the trigger. It goes into a queued state, and it's going to stay in a queued state until the speed exceeds, shit, I mapped that wrong, until the speed exceeds free flow for more than 15 minutes.
Okay. So in theory, if you have a road that drops below the free flow speed, or 60% of the free flow speed from 3 p.m. till 7 p.m. every day, it's gonna fall in that category every day.
It will, and what'll happen too is that the head of that roadway and its tail upstream, it could change dynamically. Like the dynamics of a queue and bottleneck will change over time because the center of it could disappear, but this guy's still connected to it. Just the way the definition, the algorithm works, and the math is, this could be in a bottleneck state for hours, but not all segments are in that bottleneck state for hours. But
Yeah, it's just that.
just the nature of it. So it'll fluctuate. And the bottleneck ranking report will show that pretty well, right? When you run the analysis for some time range.
It sounds like it's more of a tool designed for capacity limitations more than necessarily fluctuating conditions.
So bottleneck ranking report is excellent for several use cases. The two that come to mind for a lot of organizations or a lot of agencies is like project prioritization, right? That's hey, these are coming up all the damn time. These are choke points. Like if you look at congestion on a network map, it's just telling you where there's issues. It's largely recurrent sort of stuff. A bottleneck is a choke point. This is constricted right here. The bottleneck ranking is going to tell you, we've got dashboard tools and I'll cover those. It's going to tell you on a recurring basis what that looks like and how it's ranked. It's also helpful to validate projects, right? Project prioritization lists. So, all right, this is confirming what we thought about where we need to make improvements. We'll run that. The other thing is looking at special events or severe weather events. You can look at the results of analysis from like a temporal comparison map or a trend map, and it's going to show you where things are slow and congested and jacked up. But it might be slow, congested, and jacked up because it's recurrent or because there's signal timing issues there. But when you overlay that in a sense, you got to run two different reports, right? When you run the bottleneck report and you see that list of where the bottlenecks were, this bottleneck correlates to where that temporal comparison map told me that there was some junked up travel time reliability variations here. Then you know that, we've got an issue here. We need to keep an eye on it. We need to put, a safety service patrols here for this special event or we got to dispatch state troopers, whatever. But yeah, there's a couple of different things. I like to, like MPOs, they use bottleneck ranking all the time for their CMP reports, right? Their congestion management process reports. Where are the most bottlenecked areas, and then what is that? How does that impact the region? Because it sets the tone for where you want to make improvements. And so what I like to do, and you see a lot of MPOs do this, is they will.
More where you probably want to make like capacity improvements rather than a temporary change.
Some of these.
Good to know that's how it's doing it. Yes.
It's temporal comparison.
I know the calculation behind that. That makes a lot of sense. Oh, 3 hours, I guess.
Okay. So here's an example of how you might, like MPOs will take bottleneck ranking reports and they'll use it to embed it into executive kind of map-based apps. So this is just a bottleneck report. You just export that data out, and you can, provide additional context that you're not going to get perhaps with just out of the box with probe data analytics. So there's a little bit more information that's exposed in these pop-ups based on some additional analysis. And it's just I think it's a clean way to show where the primary bottlenecks or queues or troubled areas or choke points are for a given region. That's all coming out of just one bottleneck report.
No, that all makes sense. Thank you.
Mm-hmm. Yeah, I'd mentioned to you guys, I'm a GIS geek. I love taking some of these reports. I do a lot of training and demos for MPOs, and they all use ArcGIS. So this is a temporal comparison map. It's not a temporal comparison map. I ran some temporal comparison analysis. Sometimes you want to do corridor-based reports. How's my corridor performing in the first quarter of 2026 as compared to the same quarter in 2025? We've got a tool that does the math. It's called the temporal comparison map tool. You run the map or run the analysis, it generates a delta map, and then I just take the delta and then dump it into a map or map app, and provide these cool little pop-ups. Oh, travel time index increased by 36% from 23 to 24. It's 3D, it's fully navigable. We do a fine job with our data visualizations, right? But when you can quickly export the results and then suck it into ArcGIS Online, it makes it super compelling, I think.
I got another question. You mentioned the background calculations are getting updated roughly every quarter.
For free flow.
Okay. So we ran into challenges like this. We found it's not very best practice to compare like May of 2026 to May of 2025 because there's been enough changes and we're not really comparing apples to apples usually.
Really?
What we try to do is if we make a change, we compare like 3 weeks of April to 2 weeks of May. It's a more reflective. I'm talking about like for signal retiming, that sort of thing.
So why do you think the year-over-year monthly analysis?
I was wondering, that's kind of what I was getting at is, do you think those background calculations of free flow speed and everything else are impacting that? It's been recalculated a few times since the 2 different before and after periods.
if it's for the same corridor, you'd think there'd be some relative consistency. Have you tried multiple years? Now, instead of just year over year, just do multiple years? Well, you got data that goes back to 2017.
Well, I know, and this is going back to like 2019 or 2020, there was massive recalculations. So there was like a point where we could not compare the two before and afters. It was like everything shifted at December of 19 or whatever it was.
Yeah, there. You know what? It's reminding me there are some fundamental updates. There have been some fundamental updates to how here in NRICS calculates speeds also, right?
That might be more what it is.
And that could be a contributing factor. Like NRICS right now, they're getting ready to roll out I think by the end of this year, a newly refreshed algorithm for calculating speed that's more representative to what's actually happening on the road, with
So when the
less
change gets reflected.
with less error. And then but that's why they make a huge push to communicate to all their users that they're making that change, because they're going to see a difference when they do those year over year comparisons.
Okay.
It's more accurate now,
Right.
but when doing the type of analysis that we do with these tools, going, oh, well, that's wonky. Why is it right
Like
there?
live analysis and all of that, but if I'm trying to compare one year to another year, it starts to get challenging.
Yeah, you've already made the right jump though by increasing the time period, because you average out those speeds, right? So by expanding the time range, you're expanding the average. That's kind of the trick with all this data, right? It's not actual speeds. You're just getting an average, harmonic average for everything. Even when you interact with the segments in traffic map, like with the real-time traffic map, if you double click on a road segment and get a speed, but shoot, there could be, 5 cars going 70 and, 4 cars going 60. So the speed's going to be the mean, right? You don't.
I think we need 85 percentile.
What's that?
85 percentile, that is what they use.
Mhm.
Okay. Also, another question.
Let me get rid of this. Sorry, 80.
So, we are talking about the bottleneck, right? Like, you guys do 10 minutes. Like, what is the CV penetration rate around here?
It's highly variable depending on time of day of the week, geographic region. I always say it's statistically significant. Excuse me. So you can't have ITS sensors everywhere, but you have probe speed data everywhere.
I'm thinking like 10 minutes. Like, in a segment, like to have multiple vehicles come through, like, that is very rare.
Yeah, it depends on what question do you want to answer. Even if you have a small sample set, that small sample set's still moving with the rest of the traffic. They're not moving at a different rate than everybody else. For that moment in time, on that road segment, even if it's a small sample set, they're all working together. You're in traffic, or you're with a bunch of other cars going fast, right? You're not gonna, like on an interstate, you're either gonna be sitting still on the shoulder, or you're gonna be zipping away at 70 miles an hour, or stuck in traffic at 35 or whatever. It's statistically significant for the questions you want to answer, generally speaking. Not generally speaking, all that. That's why so many state agencies just they're abandoning their roadside sensors. It's like, they break, they got to be calibrated, they lose power, freaking work zone, the construction crews, they cut the fiber optic. It's like, That shit's going down all the time. You can't rely on that. And it's spot measures, right? This is everywhere. The entire network. Every single road. Which is cool. It's all right.
It is a comment, you know, like.
Is it?
Yeah.
Yeah,
it's what I'm saying.
What do you mean
it's
a crime?
It's right. Move on. You can get mad.
Right, that's what I told him too. I was like,
And you can do some boot camp. Yeah. Are you ready?
I don't know.
Are you
I
ready?
think you need to. My fiance's not like those one. She's nice.
She admits that she's on
Yeah, okay.
My wife's always
I think telling her she she's of herself.
Hey, Matt, sorry.
Hey, Ray.
Do you know if Navigator reports lane level information with incidents?
I think it does now. However, I don't know if the data, if the public-facing data. So, let me back up. Navigator has always had that functionality. However, the data feed that we had historically did not appropriately align with how it could be ingested for RITIS.
And was it an API or was it like an XML thing or export and in?
So the way that we have our data set
I did the
up,
math. I was like, if I spend
GDOT has their data
$40
set
on
up.
strawberries, but that's enough strawberries for the whole year.
As I
I'm not mad
understand
about it.
it,
And I only got one more jar of jam left.
they have the real database over here.
Yeah,
And then their firewall, and then they have a mirror copy over here. That gets pushed every 1 minute, I think.
okay. And that's what we tap into? Okay. But in theory, the attribution for lane closures should be in there.
It should be, stressing the word should. However, that may not be a data field. Like, I think at one point that was a data field that wasn't being pushed through the firewall. And then it was like, we kind of went back and forth. And I think at the time, we were setting this up initially, we're like, whatever, we're replacing Navigator. So let's just figure this out when the new one comes in.
And is the
new one's in.
The new one's in.
Yeah, so
But I didn't get signed up for the text.
that said, there's some.
We need to reevaluate. Is this something?
Yeah, we need to do a reeval on a bunch of the different data fields to make sure that they are all being extracted and pushed through correctly. So like,
Is this
one of
an-
the data fields that doesn't work correctly, and it's not y'all's fault, it's the way that the data is pushed, is that the vehicle detectors, by way of example,
Oh, I just noticed that while you were gone.
they update every 20 seconds. And so if you're looking at speed data, it's fine because you're like, yeah, whatever. It's not a big deal. However, in reality, what happens is that when it gets pushed through for the public face, it's overriding the first 20 seconds, the second 20 seconds, and only the third 20 seconds. And so your volumes are approximately a third
Of what it could be.
Where the screen got cracked.
Okay.
And so it's one of those things of like, that's one of those. I like using that tool because I find it easier to read. However,
it doesn't, like if you're trying to pull volume data, it's not gonna be correct.
All right.
Again, historically, that may have changed with the new database updates. But that's where I say I think it requires a reeval on that front. just to make sure, and also be like, hey,
These are some action items I think we need to follow up on.
agreed.
So,
Yeah, they're like, I mean, that like the system just went live in like May, and it's just
okay.
and it's one of those things that like, there are still items that they are trying to clean up with the rollout. But this is a low priority item.
With their updated and refreshed ATMS platform in place, this is something we need to reassess and investigate with the customer, period.
Yeah, so I think like it's there's features and functionality that is still not working as it should, and so that's where like those things are taking priority, understandably so.
Okay. All right. Let's get rolling again.
I see.
So I know when you guys step away for a break, your mind is racing through everything that Rick's been talking about. And you come back with all these great questions because this is so engaging and exciting. What are these questions you have now? No, joking aside, seriously. Any questions with regard to what I've shared with you so far? I wanted to re-emphasize this idea of congestion and bottlenecks and the difference between the two of them. You know, Kyle and I were having a sidebar conversation, the AE Comm team here, about what is a bottleneck. And I think the thing to really pull away from some of the capabilities that we've seen, both in traffic map and just looking at real time what's happening on the roadways and the network, it's kind of when you turn on that real-time probe speed data, it's giving you kind of a footprint of what's going on at the moment in time. But when you turn on bottlenecks in Region Explorer, again, that's showing you where the constriction points are, where are the choke points on the network. It's probably a problem, right? So keep that in mind when thinking about what are the tools that are available to me to really help me in either real time understand where the problems are versus just looking at speed and congestion on the network through traffic map. There are times when you're going to want to look at Region Explorer, or you want to go back in time using the bottleneck ranking report and ask, well, what were the top 100 or the top 10 bottlenecks for this area for the first quarter of 2026? Real quickly, what is a bottleneck? What is a queue? There is a definition, and it's important. The definition is relative to the speed of the segment at that moment in time, that day of the week, that week of the year, when it's being calculated. So it's like it is a firm kind of concrete explanation or calculation of, yeah, this is a problem and this is a choke point. And it gets defined when that segment for that moment in time, that day of the week, that week of the year, in which free flow speed, which is defined by here for that segment, for that time, and is refreshed regularly, when free flow speed falls below, when the speed falls below 60% of the free flow speed for more than 10 minutes, it becomes, at that point, that's 10-minute time span, it becomes queued or bottleneck state. It'll stay in a bottleneck state until the speed on that segment exceeds 60% of free flow for more than 15 minutes. So the segment's going to be in a queued bottleneck state throughout this duration until there, given that graph. I'm a really good graph maker, aren't I? I took a class in that, making graphs. So that's how you define a bottleneck. That's the math to a bottleneck. Any questions about that? Pretty unique, right? Bottlenecks, queues, where do I find them? Or how do I find them? How are they useful? We already looked at Region Explorer. How many of you think you might be interested in setting up an alert for a corridor if its speed falls below a certain threshold or goes above a certain threshold? Is that anything of interest? Maybe? Okay, I'll demo that really quickly. So Matt, remind me, you guys do not have incident alerts, you just have speed alerts?
I do, but I had to break the plan just to get that. That might be something for some other folks to check.
When you open RITIS, do you guys have a personal alerts, traffic alerts tab?
Yes.
You do. And when you click on that, do you have both speed and incident? You do.
Subscribe to the incident, subscribe to the speed, yeah.
All right. Let's do a quick demo. We're gonna set up a speed alert. So go ahead and open RITIS, fire up another tab, go to, I'm gonna close a few of these. So personal traffic alerts, you have two different types of subscriptions that you could set up. One's incidents, you can figure that out on your own. We're gonna do speed subscriptions. So click on new speed subscription. And this is basically a step-by-step process. Okay, where do you wanna set up your speed subscription? What days of the week, what times of the day? So make sure that you're using here segments, and we'll walk through some of these ways in which you can define the spatial kind of parameters of your query. In this case, the road selection. We're going to somebody give me a US route that we can monitor. 41? All right, so I just typed in US 41. There's 99, that's a big road, gee, many Christmas. All right, we don't want all of that, right? I don't want to monitor all of that. I just want to monitor this section in downtown, let's say just downtown Atlanta. And I have a little trick for defining a partial segment. So go ahead and, instead of the entire thing, click partial. And the way these drop-down lists work, it's kind of wonky. Come on in, guys.
Rick, can you go back a step?
Yep.
So you type in US 41 and search.
Sam, you got space? Somebody could sit here. And I think we have one spot right here next to Matt. So first you got to search for the road segment, right? Did you get that far?
Yes.
All right.
Back to the search and it's got like 52 roads now. How did you, I guess, filter it down?
So, all right. We're going to talk more about this in a little bit, but when you search by road name, which we're doing right now, as opposed to some of these other methods, I'm going to walk you through all of these methods. But when you search by road name, the way we set up and design the underlying database is for optimized queries for probe speed data. And it doesn't make any sense to, in context to like a consumer mapping app, like you're looking for, well, where's US 41? And, naming conventions aren't the same in this database as they are in consumer mapping apps. Because US 41 may have a bunch of names, right? Keep in mind that your US routes, your state routes, and interstates are going to have standard naming conventions that are aligned with the National Highway System, NHS. So you may think Martin Luther King Boulevard, and that may or may not align with US 41, whatever, I don't know. Martin Luther King Boulevard probably aligns with a state route or a US route at some point. I don't know. Anyway, my point is use the standard naming conventions. And when you do a search, it's going to find multiple hits. The most likely hits are going to be the segments of road that you're interested in, okay? And so just take the first one. So click that first set, and it's going to bring in US 41 in different parts of the state. All of those others in that list that you saw?
So the part that I missed, I didn't realize in that top left, we had to select the Georgia drop down to kind of pair it. So I was getting it for the whole US.
Oh, all right. So that's not set to Georgia by default? All right. So our friend over here discovered that she, by default, apparently you guys, if you've not used this before, is set to all regions. Make sure you go to Georgia before you look for US 41 or anything for that matter in Probe Data Analytics. So I'm gonna just show you really quickly how to. We'll kind of cover this again, but if you don't want all of this to be part of your speed alert, click the partial button. All right. Then zoom. This is my personal trick. I don't know, Matt, maybe you've got different ways, but I zoom into the area that I want to keep an eye on, and I hover my mouse over the road segment to get what's the intersection on, I'm going to do the northbound side. It's US 19, Georgia 9, 14th Street. This drop-down list is what lets you shrink and cut off the road segments. So I'll come in here and it goes from south to north, south on the left drop down, north on the right. So for this northbound segment, what was it? US 19, Georgia 9. So US 19, Georgia 9, right there. Boom. So notice it got rid of everything to the south, right? All of those other segments are gone. Now then, I want to cut off at the north with this drop down. Let's just say I want to cut it off at 401 Paces Ferry Road. So I click once in here, and I just look for Paces, and I just go Paces Ferry Road. And it cuts off to the north. Now you can interactively kind of click and remove individual segments as well. That's just using the road the road name methodology.
Just a heads up, if you're in dark mode, that you won't see the names, intersection names anymore.
Oh my gosh, that's interesting.
It's still selected, but it's just not selected.
So you see that? That's a bug we just found. I changed my my map mode from light to dark. Look what happens. You can't see the road name. You guys are awesome. I'm finding all these. I need to write that one down. So this is, I wonder if that happens in PDA as well. We're going to find out. Bugs. I'm going to make a bug report. All right, so this is a speed alert, right? Dark mode. No text in partial drop down. Cool, thank you. All right, so once you've defined what road segment you want in this speed alert, it becomes fairly straightforward and self-explanatory. Make sure, right? That's what, I'm gonna get rid of this one just because I'm nuanced like that. So I'm just looking at northbound. You go ahead and click next. You give it a name. You say, oh, this is northbound US 41 in Atlanta. And if the speed falls below, let's say 40%, like I'm just like concerned with congestion, like severe congestion, bottleneck, like travel time is, reliability is just absolutely awful. You can set it up way below free flow, or you're looking at a specific mile per hour value. You can do that for for a certain duration. You want to alert me, okay, alert me 5 minutes after all segments along the selected road no longer match the criteria. And then you could set up different days of the week. Like maybe you just want Tuesday, Wednesday, Thursday. Like you could do an AM peak. And then Tuesday, Wednesday, Thursday, okay, I want to do a PM peak monitoring of that segment from, let's say, 4:30 to PM peak goes to what, like 11:30 here? So you could do, set up AM, PM peak, different times of day, enter your email and your phone number. You can do one or the other, you can do both. And when that road segment that you defined meets the criteria you defined, you're going to get an email and a text message. It's pretty cool, actually. So that's speed alerts, and you'll figure out incident alerts. It's essentially the same process. In incident alerts, you actually have to define the route. But it's basically the same. All right, let's talk about dashboards for a minute. So we've been, again, two primary sets of capabilities within RITIS: real-time situational awareness, the analytics, all the real-time stuff is going into RITIS. It's being archived, and then you've got some cool tools that we'll explore in a little bit in terms of how to query that. But there's also a suite of capabilities, these dashboarding tools, that let you kind of measure or look at what's happening in relative real time compared to historic conditions. So when you think of dashboards, they're kind of an indicator of, what's happening now, kind of measuring real-time conditions. So each one of those bullets represents a different widget. You could create and configure your own dashboard that gives you speed and travel time indicators. We're going to cover that because that one's crazy, crazy cool. This image right here and you guys over here cannot see this. This right here, this is a speed and travel time widget that was set up for this larger dashboard. these are all different widgets for this one comprehensive dashboard. Each one of those different bullets represents a different type of widget that you can add to a dashboard. Bottlenecks, like, there's a ranked bottleneck comparison widget. That one's super cool. You define the geography or the roads that you want to create this ranked bottleneck report for us. So like Kyle, we were talking about bottlenecks. This is kind of an interesting spin in that you can focus geographically on where you want to keep an eye on top bottlenecks or top choke points within a specific area, and it'll rank it. It'll rank all the corridors over the last 12 months or 14 months or 24 months, and it'll put it into a ranked table. User delay cost, obvious what that does. Event clearance times, event counts, and map 21. All of these are different widgets that you can add to your and configure to your own dashboard. So let's why are we doing that? Kind of measuring real time against historic conditions. This is the event count widget. This one actually works for you guys because we're capturing and collecting your events, and they're all classified by event type. So let's go ahead and let's just jump out, go in, and let's create your first dashboard with a couple of widgets in it. So where do you think you're going to find dashboards? It's not totally obvious. So it's not a real-time tool, but it's not also exclusively an archive tool. But it kind of is. Sorry about that. So when you go to RITIS, if you go to the Data Archive tab, all the dashboarding tools are going to be within Probe Data Analytics. So go ahead and click Probe Data Analytics again. We've done this already. But go ahead and click that and open up the landing page for Probe Data Analytics. Scroll down until you find, where's dashboard? Did I pass it? There it is. It's going to look like that. Now, we'll walk through the PDA landing page, get you guys familiar with that more in a little bit. But for now, go ahead and click Dashboard. Is everybody there? Yep, thumbs up. Thumbs up. All right. You have probably not created a dashboard yet. So it's probably going to prompt you, create a dashboard, right? Is that the first thing? If you hadn't created a dashboard, does it prompt you to create a new dashboard? Oh, you got to click a green button. Yeah, so click the green button. Let's just call your dashboard whatever you want. It's your dashboard. All right, so give it a name. I gave my dashboard the name G.Spring 2026 dash. I could go in and edit that and call it, I don't like dash. I actually want it to be dashboard. All right, so rename it. All right, you've got a blank canvas. So there's a couple things you could do here. You can, if you have several dashboards already, in the upper right-hand corner, you could select the dashboard to view. You can add a new dashboard, add a widget. This one's kind of cool. How many of you have a G.dot email address in the room? All right. How many of you are logged in with your Gmail or your G.dot email address to RITIS? Okay, so those of you who just raised your hand, this is gonna be cool. I'm gonna share my dashboard with you. What's your Gmail domain?
DOT.ga.
At dot.ga.gov.
.ga.
Yep. All right. So, if you guys refresh your browser and now click select the dashboard, you will see G.Spring 2026 dashboard in there. Correct? If you're logged in with your DOT email. So that's a starting point for you to go back to. You know, hey, I couldn't follow Rick because I was dorking around on my phone. You at least have, you know, something to look at. I'm going to just walk through some of the widgets that are available. Again, we're going to cover this one in more detail. The speed and travel time, super important, particularly for SIGOPS, because it allows you with incredible fidelity to keep an eye on the real-time conditions of corridors and perhaps give you a visual indicator of when there's a problem before you get an indication from any other source. Maybe it'd be 511, 911, or other like, you know, phone calls from the public. Ranked bottleneck table and ranked bottleneck comparison, both of those are essentially the same. I included a ranked bottleneck comparison. All of these widgets are designed for you to define the road segments that you want to monitor. And then it gives you, you know, these cool little insights about like what's going on. So I'm gonna just draw a box around downtown Atlanta. Say, I don't care, all roads, all classes. It's gonna select all the roads. I'm gonna add those. And for this rate bottleneck table, I'm gonna have it give me the state, the length, the duration, display the 10 longest. I can change that. Maybe I want the 15 longest bottlenecks. And then I'm gonna call it ranked bottleneck table, and then add that widget. It's gonna add it to the bottom of my dashboard. So it's preparing that now. Oh, actually it's prepared it already.
Quick question. So when you're selecting your roadway segments, the only way to really, so like in Georgia, we're divided into different districts. We don't have an option to like say like District 3. We would have to like do a polygon around the whole district.
Are your districts generally coincident with county boundaries?
Yes.
In PDA, not the dashboard tools, in PDA, you'll have that kind of geographic fidelity. You could choose roads within counties or roads within zip codes. So there are some geographic spatial query functions that are exposed there. Interestingly, I'm not sure why it's not exposed here.
Is there a way to make county groups?
Yeah, you do it. You decide which counties you want as part of that query.
Can I say, okay, so like, let's say I want these 30 counties as one group. Can I just say that as a group to use in different queries?
Absolutely, and we're gonna cover that. That was great. Her question was, I'm gonna run analysis on the same roads that are within my jurisdiction of interest on a regular basis. Do I have the ability to save those? Yes, you do, and I'll cover that when we jump into probe data analytics, but it's a great question. So anyway, I don't want to spend too much time on, you know, the various different widgets. What I do want to spend time on, though, is the speed and travel time widget. And if you guys on this side of the room can direct your attention visually over here for just a minute, remember that I was I talked a little bit at the beginning of class about TMC segments and the other one is TS segments from here. So here has two fundamental spatial road databases. One of them's TMC, traffic message channel. That's kind of an old nomenclature for, when older cars, the original nav systems, they had the CD in the trunk that helped them kind of with navigation. The real-time traffic was coming in over the air through literally a transmission, a frequency channel, and it would communicate via a single ID which roads would be green and which roads were yellow and which roads were red. So this is kind of an old nomenclature that's internationally accepted. TMC segments on roadways are generally very long. They could be like in your rural areas, you could have TMC segments that could be 5 miles in length. Crazy long. In urban areas, they're going to be smaller, but unlike TMC segments, the same, like let's say this is exit 22 and this is exit 23 on I-75. A TS database, the same stretch of roadway, it's going to have, it could have 5, 10, 15 little bitty spatial road segments that it's capturing the speed for. So think about, your work in SIGOPS. Like, if you want insights on a corridor and how it's performing and where there might be problems between, for a 5-mile stretch of the corridor, do you think a single TMC segment's going to give you the insights that you need? No. So you need the TS data, all right? That being said, unfortunately, in these dashboards, you're limited to TMC data. In Probe Data Analytics, you're gonna have access to this TS data. The point is, though, that the more spatial fidelity that you kind of look at speeds along a corridor, the better insights you're going to have to where and when a problem's going to pop up. So, look at my dashboard. You're going to see 1, 2, 3, 4, 5 roads or 5 segments that I defined for my speed and travel time widget. One of them is I-75, I-85, the whole damn stretch, every bit of it. Now, right now, this time of the day is not a good way to kind of do this analysis. But by looking at the entire stretch of I-75, I-85, it's averaging out all the speeds on all the segments that make up that entire corridor. And it's like 50 miles per hour. But I'm gonna expose that I actually broke it up to give myself more fidelity, spatial fidelity and insights to what's going on within the corridor, segment by segment. So instead of looking at this whole stretch of I-75, I-85, I actually broke it into, let's make this a little more visually clear. I have 1, 2, I'm gonna flash, no, oh, that's the entire segment. So see how that blue segment, that represents the entire stretch of the corridor. Oh, it's 58 miles per hour. But I want more fidelity in knowing what's going on from a speed and travel time perspective. So I went in and I said, you know what? I'm going to define smaller segments to comprise my speed and travel time dashboard. So I said, it's more meaningful for me to know what the speed from here to here is and here to here in between these signals, right? Or in between these intersections, as opposed to knowing the speed for that whole segment. Well, I probably should have cut it down. But anyway, the point is that the speed and travel time dashboard during game day, the World Series or World Cup, that thing's going to generate a really terrific, if you configure it properly, can generate incredible insights on where there's not necessarily bottlenecks, but where you could have a problem before a problem's reported. Because you've defined these smaller segments to make up the corridor that you're monitoring. And when speeds and travel times fall below a certain threshold, these numbers are going to change color because it's being updated like just now. See what happened? That segment of northbound I-75 Pryor, between Pryor Street and Memorial Street, its speed just changed from 39 to 34. Or the free flow, the speed should be 39 based on historical patterns, but it's now 34. Question.
I have two questions. Number one, so with the exclusion screen automatically refresh itself, or you have to hit the refresh button?
Does the speed and travel time dashboard refresh itself? What do you see in the lower right-hand corner of my speed and travel time dashboard? It is counting down. Every minute, you're going to get a refresh to what's going on. That's why I have that slowdown of 5 miles per hour. If there's a big problem, you're going to see some, red or maroon. Like maroon is real bad. And that's like afternoon peak. If you bring this dashboard back up, you're going to see all sorts of problems here, right? Because it's right downtown. Is it a problem that you need to pay attention to? I don't know, but it's another measure for you to use for kind of understanding what's going on, what sort of patterns of mobility behavior are happening during game day, or just any day for that matter. But good question. What's the second question?
Second question. So you shared this dashboard with us, right? And I see that it has this editing view. So if you shared it with us and we made changes, does it change it for everybody?
You can't change it.
I can't change any of the partners.
I should have.
The author's the only one that can. The author's the only one who can modify. Like you saw me go in and click the pencil button. You can't do that.
We can save it and it downloads, but there's no way to okay. So here they have this.
Oh, that's just a
export,
save as.
So I can export it, but there's no way for me to
Is there a way
To copy it.
Yeah.
Yeah.
I have to start from scratch.
Yeah.
And then my other question, I guess my third question is there a way to assign another user editing permissions for your dashboard?
Yeah. So there are agencies that set up these SOPs for building out dashboards that are used throughout the state. So somebody will be in the district, they'll be responsible for creating the dashboard. They go through all the work because it is freaking tedious to set up a speed and travel time dashboard. I'm not gonna sugarcoat it. It's super tedious, and I'll show you why it's super tedious in a little bit. They set it up and then they share it. The idea that you can't have multiple people have edit capabilities to a single dashboard. One person can be the author, and he can share it out with a broad group of folks. And that's kind of the SOP that we've figured out is typically used. But having one person be responsible for keeping it updated is good. Now, you guys have, I'm thinking that soon you guys might have access to TS segments for your speed and travel time dashboards. So what'll happen, just keep, and Matt, put this on the to-do list, running to-do list. Hey, when will TS segments be exposed for our dashboards? Because XD segments are in there for INRIX customers. So here's the caveat, right? You set up all these speed and travel time views within a dashboard for your district, and then all of a sudden the TS segments are turned on for you, which they will be eventually. It's all jacked up. So you got to start all over, which is fine. And you're going to want to do that, but it's just going to be jacked up, right? But here's what I mean by tedious when setting speed and travel time dashboards up. One of the things, I'm just going to collapse all of these so I'm not distracting from. Turn all of this off. All right. You know what? Screw it. I'm going to go back and just start from scratch. So if I want to create a new speed and travel time widget within my dashboard, click the add widget, click speed and travel time. So pop this thing open. By default, you guys should have TMC and here selected. If not, make sure you got here and TMC. Notice you've got no other way to identify what roads that you want in your speed and travel time widget other than by the silly road name only method. So you have to hand jam this stuff in there. So let's go back to that US 41 example, which is all over the state. So we just type in US-41, go ahead and add it. All right, clearly we don't want a speed and travel time dashboard widget for all of that. But, oh, you know what? Just for fun, let's do this anyway. By the way, all of these widgets can be, you could click and drag them and move them to different locations within your dashboard, in theory. So right now, look at this. All of US 41 for the whole state of Georgia, average speed, harmonic mean is for northbound, it's 40 miles per hour, and for southbound, it's 39. And it's going to take you 3 hours and 47 minutes to go northbound and 3 hours and 51 minutes to go southbound. Well, that's not what, as SIGOPS folks, you want real-time insights relative to historic conditions on the nuances along the corridor. What's happening between signals, right? So we're going, no, that's not what I want. I'm going to come back in here. I'm going to get rid of southbound. Let's just focus on northbound. And go to the partial button. Remember we did that with the speed alert? Click partial, and we'll just do the same thing. Just say, okay, well, I want to start measuring from exit 25A northbound along US 41 or exit 252. So I'm going to say, I'm going to come in here and say exit 252. And I only want it. Where did that go to? Huh. This is why it's a pain. Because it looks like there's several segments that have an intersection, that have attribution, or the intersections at exit 252 going clear below where I want it. So what you do is you got to come in here, remove that one, and remove that one. So now the next, I just want to measure like from one intersection to the next. So the next intersection is right here at Wesley Road. So I'm going to come up here and say, okay, Wesley, and it's going to cut it off. Man. Oh, you know what? I should just say, yeah, just go to Wesley Road, but then remove that individual road. Now then, okay, I'm monitoring that one segment of roadway. Great. But I want to monitor the whole corridor. So now you got to go in, add US 41 to then add the next segment of the corridor. And then you got to piece it together manually. Painful as it might be, tedious as it may be, it is the single best way to get a visual alert to where problems are on corridors that are important. So you got to go in here, type in again US 41, get rid of the southbound segment, look at the northbound segment, partial, say, oh yeah, I want to go from Wesley Road now. I keep wanting to spell it differently than it is. So now I'm going, sometimes I like to turn this one visibly off so I have context. Okay, yep, that's where I want it to start from the south. And I want it to go, well, the TMC segment basically takes it to Wesley Road. So I need to just cut it off at Wesley Road. So now I've got one more segment. So I'm going to do one more segment just to demonstrate how this works. US 41. Add both directions. Get rid of southbound. Partial northbound. Go from Wesley southbound, or the southern end. But actually not Wesley. I guess the next one, Collier? No. North side? Yeah. And then let's just say I want it to go all the way to this road, which is Mooresville Mill Road. So come in here and say Moores Mill Road, and it cuts it off at Moores Mill. Change that to orange. When you're doing interstate-based speed and travel time widgets, super useful as well, because you can get go from exit to exit when you get these alerts. So now that I've set this up, I now have 3 segments or multiple kind of sections. I could change the name in here if you're interested, like, because it's just pulling out of here's database these road names. You can say, oh, the south end and the midsection and, north, whatever. And then when you save the widget, go to the bottom. Where'd it go? There it is. So now I have a lot more fidelity, and I'm getting, oh, these small little segments are, now showing me at 22 miles per hour, 27, 27. There's no change in travel time really. But do you get the idea? When you're setting this up, it could be really useful for corridor monitoring, because you'll get this, we've got state agencies where they built out for key corridors all over the district. They've built out these speed and travel time dashboards, and they've got it on like 3 of their monitors in their TMC, because they can look at the speed and travel time dashboard. They'll see a maroon color for a specific segment. Why didn't it change? Did I not hit commit? It should have changed name. Anyway, you'll see a maroon for a certain segment of roadway on a key corridor, and go, oh, hey, turn the CCT camera over here. Or, hey, do we have a safety service patrol? Can they take a look at this? That's been, the travel time differential's like enormous. Something's going on there. And that's kind of like the Region Explorer with bottlenecks and queues. That's giving you a spatial indicator, but when you could pinpoint and target it through your own configuration, very, very insightful, very useful.
Okay, so you can spend a lot of time creating your segments and making them in a group. Is there a way to just share those predetermined segments with another group?
Yeah, all of these segments that go into definition for these is, and I'll cover this in a little bit. Oh, that's interesting. Notice that button at the bottom, show segment IDs. These are the 1, 2, 3, 4, 5 TMC segments and their unique ID. I was talking about GIS integration earlier. This is how I do the GIS integration. You get a shape file or a GeoJSON file, and every single segment has a unique ID, and you just do a join to bring in the performance measures from Probe Data Analytics. So those are all unique IDs, and you can repurpose them however you want in RITIS. But yeah, I'm not sure why didn't that take? That's why I didn't hit enter. South, Central, and North. Now it should change. Ready? There we go. All right, lots to explore in there. I'll just touch on this really quickly. There's that ranked bottleneck table that I added. This is basically just showing you in real time relative to historic conditions. The top 17, because I defined 17 bottlenecks in the geographic area that I defined. This is your clearance time widget. Like incidents have a start time and an end time. And this kind of gives you an update on how you guys are doing from a clearance time perspective for all the incidents that are reported for your agency. This one's kind of cool. And I think it's interesting, the ranked bottleneck comparison. Typically if you select all of Atlanta, the top 3, 4, 5 bottlenecks are generally going to be ranked top 3, 4, or 5, kind of month over month. But then you get these weird outliers. Like, okay, well, like right now, number 9, the 9th ranked bottleneck within Atlanta region, I forget the geographic extent. It's 9 this month, but in December and January, it was ranked 3rd. In October, it was ranked 3rd. It's like all over the map. I-85 South at Indian Trail, Lilburn Road. Why would that be so variable? Does anybody have any local knowledge? on that? I mean, I don't know. But it's giving you this insight that, oh yeah, this is a pretty standard pattern. Like these two are swapping second and third. You know, this one's highly variable. Maybe there's a work zone or something on there that's been active for a few months, and that's what threw it to number 3. Like this number 9, 9th rank. Maybe they had a active work zone from October through January on I-85 northbound at Indian Trail, Little Burn Road. Is that possible? Maybe. I don't know. But it's a nice snapshot. So those are the dashboards. I encourage you, again, keep in mind with dashboards, it's like this cool kind of combo of real-time awareness in context to historic conditions. So you're getting this nice snapshot of, combo of real-time traffic map and, some analytics, this archive of rich data that we got going back for years. But now you could, bring this stuff up and use it to provide some decision making. Any questions about the dashboard, widgets, tools, so forth? Is our break at noon straight up, or was it? Okay. All right, I'm going to show you one more tool before we break. Oh my God. All right, one more tool, and then we're going to take a lunch break, okay? So go back to the RITIS landing page, right? Transportation system status. Click on the data archive tab. The default tool from the data archive tab is the event query tool. The event query tool, what do I do with the event query tool? I query my events, Rick. What do you think I do with the event query? So there are a lot of ATMS platforms and systems where, you're getting these, the operators are logging in real-time events as they unfold, opening, closing them. They get put into an archive. They get put into a database that they have tools that let you query them, but they typically get backed up after so many months, right, through the ATMS system. The event query tool is your perpetual entry to querying any event incident that has ever been captured by GDOT or Waze going back to 2017. It's like awesome. How do you use it? All right. Just find your state, expand that list, say, okay, what do you want? Do you want GDOT data? You want Waze data? You want both? Let's do both. You have different ways to filter even further. I don't like dorking with that. Keep in mind, do not put a huge date range for this. It will take forever and a day. So I encourage you to not, maybe like just for demonstration purposes, just start with a couple of days. If you need a data dump of, let's say, more than 6 months, you guys have a lot of incidents in Georgia. If you need a data dump for more than 6 months for the whole state, send our support team, support@ritis.org, a request, and they can do it offline and not impact the rest of the community of users. That'd be helpful. So just think about how many incidents you guys actually record. But a couple of days shouldn't take too long here. Submit your query. What's nice about the event query tool is that it has 3 kind of integrated and synced up visualizations of the events. There's a tabular list, tabular view. There's a bar chart that has different ways to spin and look at the incidents. And then there's a map view. And what's nice is if you filter the events in the tabular view, the bar chart, the graphs, and the map filters as well. So there's this dynamic relationship between the table, the bar chart, the charts, and the maps. See how long just 3 days is taking? It's like, and that could be because, I maybe have a poor internet connection. It's noon on the East Coast for us, so there's probably a bunch of people running analysis. You got 2 months? Okay, so several of you have performed queries. That's why this is taking long. So for me, it's probably because I got in line behind all of you when submitting my request. But hopefully it comes up soon. A couple of things I want to point out about the event query tool. Most people use this to quickly and easily just query events that all the events that were recorded, and they're going to take it offline and do something else with it in Excel or maybe a map app of their choice. Maybe you want to do some safety related analysis. This isn't safety analytics, but it's a safety, you can use it for some basic safety analysis. It's frustrating. When that table comes up, and Justin can confirm this, only a certain number of columns or fields actually pop up. Are you USB-C? No. Thank you. So there's only, there's only a certain number of fields that show up by default. And you do have the ability to add more columns by hitting that blue button there. And a lot of times people want to map this data. So before you export your results, make sure that you turn latitude and longitude on. That's kind of a hidden feature. And when you do that, they show up over here to the right, okay? That's something that some people just kind of know and are familiar with. Every report, every analysis that you run in Probe Data Analytics or Event Query Tool, you can actually export it. See that blue floppy disk in the upper right? That's export. And so you could take the results and export them to a CSV and do whatever you want with it. Now keep in mind, it's only going to export whatever fields are currently active, right? That's why if you are going to map it using Esri or some other mapping tool, make sure you turn that stuff on. But here's the other thing. If you filter your data, let's say you want crash, it's going to filter out of 26,000 events that Justin queried, only 3,000 of them are crashes. And I could see that. Let me hop over to the chart. Let's look at these by day of the week. That's always fun to look at. What are my trends in terms of collisions per day of the week? I can look at hour of the day, AM peak, PM peak, and what county. It's kind of cool, right? And then there's the map view. Now the map view is only going to show me 3,000 events. So if I go over here and I say, all right, I only want location. Let's say I only want the crashes on I-75. It's going to filter out. I now only have 615. If I go to my map, it's just going to be the crashes on I-75. And when I hit export, is it going to export all of my original records or just the 615? Just the 615. All right. So if you're dorking around with your filters and that's all scale dependent, by the way, as you zoom in. Sorry, Justin, I'm not sure how to continue to zoom in. Anyway, you can, the green pluses just mean that there's more events within that particular area. As you zoom in, you can then investigate individual events. It's kind of cool. That's the event query tool. And that goes back 8 years. 8 years worth of your data, probably even more if you query Waze events. But please don't perform massive queries or you're gonna choke the system. If you need more than 6 months, again, just send support an email request and we can do it. Thank you, Justin, appreciate it. And we can do that offline for you. Any questions about the event query tool before we break for lunch?
I have a question. Can we get that, like this table or data through the API you mentioned in the very first thing? Or like, what's the API?
I would presume so. I mean, you can, so the question was, hey, can we get these events through an API? We have 2 API libraries, one for real-time content and one for the analytics. You can plot incidents on a trend map and congestion scan. So that implies that the API would expose your ability to query incidents. I don't know if you could query them independently. That's why most users, if they just want incidents, tell us what you want for whatever time period through support@ritis.org, and we'll do an extract for you. Yeah. But you can also submit a request to, hey, can I pull events as part of leveraging the API? I don't know. So it's a good question. Any other questions before we break for lunch? Okay, let's reconvene 105. Let's a little bit deeper into probe data analytics, which is, this morning we've been talking largely about all of that real-time situational awareness capabilities within the RITIS platform. We did talk about Region Explorer and dashboards, which is that kind of combo fusion of real-time relative to historic conditions stuff. Now we're going to get into the meat and potatoes of why and how most of you have actually already used RITIS. A good majority of you have already used RITIS in some capacity or another. And the part of RITIS that you've probably used is probe data analytics. There's a whole boatload of cool little tools within probe data analytics that let you ask questions of that rich probe speed data from here and derive information or insights or intelligence about what's going on your corridors in the region and on your network. In probe data analytics, the value is all of that stuff that is coming in to RITIS again, we're ingesting that, we're archiving it, and then this intelligence platform supports some of these queries, help you with all sorts of different use cases. A lot of you are doing corridor-based analytics. Oh, by the way, is this turned on, the mic? It was turned on when I was in the bathroom as well then. So when I was washing my hands, you might have to do some filth cutting. Sorry. When you think about analytics, it's not about the tool or the data visualization. What's the use case that it's going to support for me? And there's a whole boatload of different use cases and how, subject matter experts like you are using these tools on a daily basis all over the country. Project prioritization, Kyle and the group here from AECOM, we were talking, okay, the bottleneck ranking report. We call it the bottleneck ranking report, but what are the use cases for bottleneck ranking report? Oh, you know what? I don't have a standardized project prioritization process or methodology within my district or my MPO or whatever. I'm going to use the bottleneck ranking report, run it for my district for the entire year, and it's going to give me a list of the most jacked up corridors within my district for the last year. And that becomes my priority list of where I need to maybe pay attention to. Or maybe you have a workflow or procedure or methodology for developing project priority lists. Validate it with a bottleneck ranking report. Work zone safety, system performance reporting, weather impacts. Melvin was talking about precipitation. You guys are, I would think, pretty interested in understanding the impact that weather has had on your network, on your corridors, right? Okay, the tools, the data are there to help you answer these sorts of questions, and that's all within PDA. This is the Probe Data Analytics landing page. I want you to take note at the bottom of this slide of that URL. If you want to do analysis, don't go to ritis.org and click to try to get to PDA. Just remember pda.ritis.org, and that takes you right to PDA landing page. On this landing page, there's a lot going on. I'm going to give you a quick overview here in a minute or two. In the slide deck that I provided you is also a link to our best practices handbook. You'll love this. If you're new to RITIS, if you're an existing RITIS user, this handbook is a great guide for, hey, here are the tools that are available to you. This particular tool, here are the performance metrics that are generated from it. Here are the typical use cases. Here's how to set up a query. Here's how to interpret the output data visualization. It's a wonderful kind of digital user guide, if you will, that I think is better than our help system. We have a help system for Probe Data Analytics, but this is I think it's a well done document. I want to thank Oregon DOT. I always try to acknowledge them. It's the beauty of the RITIS community is that it's like a pooled fund kind of relationship where you're part of the family, and if you decide that you want to take on and own a part of the platform, like building out, like Oregon DOT, they paid for and funded independently the development of this handbook. And then they gave it over to the RITIS user community, and we basically, cleansed it up so that it was not Oregon DOT branded, so that everyone has access to it. So thank you, Oregon DOT. GDOT does this for certain tools. They'll pay, you guys will pay for a specific feature to support your operations, your use cases, and your planning needs in the agency. And that gets propagated and is available to everyone. So it's a really cool shared pooled fund sort of kind of deployment, business and deployment model. This is something else that I want to bring to your attention. This is something I developed out of a combination between that handbook and a matrix of performance measures per tool for Probe Data Analytics. I've called it the PDA Tool Metrics Explorer. If you go back to open up the training website, go.umd.edu, I'm going to point you to this right now. In the upper right-hand corner, you'll see a link to the PDA Tools Metric Explorer. I put beta in parentheses because I'm not a developer and it's not thoroughly tested, but I'd love your feedback, right? So the idea is search for a metric that you want to, like, okay, Rick, I need travel time reliability for my analysis. Okay, TTR, type in TTR. What tools will generate travel time reliability for me? You type it in and it'll filter out the tools that have travel time reliability. Or you could type in a use case. All right, maybe one of the use cases that we've documented is included in this tool explorer. But I think it's a cool kind of way to explore the various different performance metrics or measures that are available out of the box with PDA and help you navigate which tool will actually support that. And I think the links to the tools themselves is still working. I'm not, like if you click, yeah, if you click that, yeah, okay. So it's nice, right? It's a cool way to just kind of explore the different tools that are available. A lot of times we have, and I'm gonna touch on this in a little bit. While we give you an easy way to query probe data using the various different tools and analysis, keep in mind that sometimes your leadership and the general public, or maybe legislators, whoever it might be, they want specific types of executive level reports. And something to remember is that PDA helps you generate the data, the intelligence, and the knowledge about what happened for a particular time or relative to other dates and times. But sometimes you need to pull it all together, all these different reports, and you need to synthesize it and aggregate it into a single integrated executive report. Now, I'm going to talk about this later, but we have a bunch of report templates that are curated from a host of different agencies all over the country. Hey, this is how we report on special events. This is what our report template looks like. And then, like in this case, all you're doing, it's kind of interesting, is you're running one report for trend map, 2 reports for user delay cost, and the third report is for performance summaries. So all of these graphics and visuals and information, it's all configurable, but to get this detail, you run 3 separate reports and you just dump the metrics and data visualizations into the report. So this is it's just a couple of examples of how Probe Data Analytics out of the box, really cool performance measures that it delivers and really cool data visualizations, but you can create all sorts of beautiful visualizations or beautiful executive level reports using some of our report templates. So let's dive into Probe Data Analytics, doing some query, just like the basics of setting up a query within Probe Data Analytics. We're going to do that. We're going to focus on the trend map right now. Although in the analysis, all the reports that I provided in our training resources, they were for a congestion scan. They were for a trend map. No. Actually, these are just examples of different sort of tools and reports that come out. The analysis that I ran, and we're going to review in more detail, was a performance chart, user delay cost, a trend map to help with that, help build out that MLB use case report. So with that, let's dive in. Let's open up PDA, and let's start with a basic query. Like most of you know how to set up a query in PDA, it seems like. But as a refresher, I'm going to walk through it with the whole group. So what we're going to do, oh, good job, guys. Got your names in there. What's that URL that I wanted you to go to? Don't go through RITIS, just go to pda.ritis.org. When you do that, it's going to take you to the PDA landing page. Just quick orientation for the PDA landing page. I have more tools than you do, perhaps, most likely. So don't worry yourself about not seeing everything that Rick's got on his PDA landing page, but you probably have a good majority of these. We don't have enough time to go through all of this. I'm barely going to have enough time to cover some of the most frequently used tools: trend map, congestion scan, performance summaries. Matt made reference to our energy analytics tools. They're 1, 2, 3. If you're doing any sort of emissions-related analysis, you have a boatload of tools to help you understand emissions at the corridor level, at the road segment level. Heretofore, I think most models are only able to calculate emissions-related performance or metrics, KPIs, at a geographic level. These tools expose the moves model and calculations and algorithms at the corridor level, which is crazy stuff. So I encourage you to explore that if you have a chance. Just quick orientation. All of this quick shortcut toolbar at the top, you'll see that in every tool, regardless of, if you're launching a congestion scan, you're going to set up a query for congestion scan, you're going to see that quick launch toolbar at the top of every tool. It's just a quick launch toolbar is all it is. In addition, in the upper right-hand corner, this kind of standard quick links, quick links to our templates page, which I'll cover later. These are these templates that I was talking about, curated templates for taking the results of your analysis and dumping them into any one of these. All they are is PowerPoint files. Everybody knows how to work with PowerPoint. You just download the PowerPoint file and dump in and configure your metrics. Next, over tutorials. We've got a fairly comprehensive group of tutorials that kind of characterize some very basic elements to setting up a query or exploring different tools. So that's a resource for you if you're interested in checking that out. The help system is pretty good. Pretty good documentation in our help system. It's one massive HTML file. There is some general organization to it in terms of general kind of data topics, NPM, RDS, map 21. So if you go into these individual categories, you say, hey, I want to better understand here data, and I forget who was asking me, like the frequency at which free flow speed is calculated or updated. I don't know if it actually tells you here. Reference speed, the calculated free flow speed, mean speed, railway segments, miles per hour, the actual is calculated upon the 85th, which segments, okay, they don't give you the cadence in which they're updating that.
So it's not based on speed limit, it's based on 85th percentile.
For here it is. Yeah. Yeah, INRIX does it a little bit differently, which is what I'm kind of used to. If you want to explore an individual tool within the help system, just go down to the tools section, go, oh, what does the corridor speed bins tool do? Oh, well, the corridor speed bins takes all observed speeds and puts them into bins. I actually like, I'm not going to demo the corridor speed bins tool today, but I encourage you to check it out. Most of the tools in Pro Data Analytics, what is it giving you with regard to speed or other performance measures like travel time or percent congestion or comparative speed or planning time in? Those values are derived from, are they derived from exact observed? No, it's all averaged values. It's averaged out for the segments. It's averaged out for the hours and days that you're analyzing. On the contrary, corridor speed bins, we're taking every observed speed for that road segment during the time period, and we're binning them. So we're putting them, every observed speed, we're putting them into different buckets. And those buckets kind of end up looking like this. So there's different measures here, but speed's typically the one that most people are looking at because they're interested in looking at, well, how much of all the observed speeds during the period analyzed were 60 miles per hour or greater, or in this, like this purple color, less than 10 miles per hour on I-95 for this 23-mile stretch. Do any of you deal with excessive speed at all? No, because you're in the urban area. Although I do think it's a problem in certain corridors. This is a cool tool where it's designed out of the box to try to characterize persistent congestion and, highlight where slow speeds or problem areas are along your corridor. But you can flip the thing around and change the color schemes to find excessive speeds, which is a really, really important function for some agencies. But anyway, explore the help system. I think I mentioned that it's one big HTML document. Why is that important? Because there's no search feature in the help documentation. So if you want to find something, you have to use the browser search. So Control F and say, I want to find travel time. I want to do something on travel time. And it'll go, there's 150 references to travel time. And you go through it, right? It's kind of clunky, which is why I built the Explorer, the metric Explorer, because it's a little, in terms of figuring out performance measures versus the connection to tools. The next area, or the other link in the upper right-hand corner is to your history. If you click My History, that's going to open up. Every report you've ever run is saved in perpetuity until you do this, until you click I'm going to go down to one that I know I can get rid of until you physically go through, hit the trash can. Oh, you want to delete that report? Yeah, I do. I mean, I've got thousands of reports, and I don't clean this stuff up like I should. But anyway, we keep your reports. You can, on the left side here, you can click the groupings by, report type, trend maps, performance charts, performance summaries, bottlenecks. I encourage you, when you run any analysis, go ahead and put a title name on it because it makes it easier to find it later. Notice how it's highlighted, it's bold, gives you kind of a visual indication really quick. Oh yeah, that's that report that I ran for Taylor Swift concert. Or, oh yeah, this is the trend map that I ran for the Beyonce concert. And then I think, and then it's also, you could also use the browser search field to find that report pretty quickly because there's no search function on the reports that you've run. But if you start using some standardized naming conventions when you're running reports, it just makes it easier for you to find it and also for kind of reference for others. Okay, so that is kind of the top header bar for probe data analytics. Anybody know what this is in the upper right? What's new? Blah, blah, blah. Has anyone ever clicked that? Raise your hand. Oh man, you guys are learning so much new, cool stuff. Yeah, that's our release notes. So when you click what's new, it opens up a gigantic HTML document with release notes. So every substantial or incremental update that's made to probe data analytics, we're going to give you a little bit of documentation on that. Let's see, this is new to me, May 14th. Today's release adds line charts to the dashboard's speed and travel time widget. Displays the readings for each selected corridor over the course of the current day. How do you access that? Oh man, I closed my dashboards. Okay, now I want to look. Now I want to see that. Line bar charts, speed and travel time. Am I missing something here? Oh, I wonder if that's in the configuration. And I just missed it altogether. Huh. Anybody else figure that out? I am reading this properly, right? Speed and travel time. Oh, the table widget. Yeah, that's what we were working on.
I think you have to double click the setting.
Oh, you know what? That's what it is. It expands. Oh, very cool. Look at that.
That's new.
That is new.
Okay.
So here's the one that we created together earlier today. Oh man, look at that. That is beautiful. Whew. All right, cool. Hey, I even learned something new today. That's why you click that what's new banner in the upper right-hand corner. You learn all sorts of, just kind of, you could go through and see, what the new release info is. This was a big one. I'm going to touch on this. We released a new work zone performance reporting tool. Lets you create this beautiful 6-page performance report for work zones, for existing work zones, or you define the work zone and the corridor to get these performance reports. All right, that's it for orientation. So are we ready to create a query? Set up, do a query? Who's gonna come up and demo?
Yeah, I'll do it.
You'll do it? The clear guy user. And if he can go through it, anybody can, right? No, I'm just teasing. All right, so I'm gonna walk through how to set up a query in Probe Data Analytics. The thing to keep in mind with Probe Data Analytics, every single tool, there are two primary parameters for every query. There's the spatial parameter, what roads do you want to run your analysis on, and the temporal parameter, what date ranges do you want to compare, contrast, and look at. Two parameters, spatial, temporal, essentially the same for setting up any query in Probe Data Analytics. I like to start with the trend map because it's my favorite tool. It's map-based, and I'm a map guy. But it also gives you every single option for establishing your spatial query or the spatial parameter for your query. So let's do this together. Go ahead and open PDA, start a trend map or open trend map query. Make sure that you are in the United States and not the United Kingdom. Make sure you are using TS segments from here. And we are gonna, if you want, you can zoom in a little bit, but if you're looking to create a trend map for a specific corridor or series of corridors, sometimes it's nice to use the find feature. Think of in the upper left-hand corner of the map frame, you could zoom in, zoom out, recenter. I think that's, or zoom to center map on selection. Anyway, but there's this find feature, location search. So maybe you're looking, we want to do some analysis in and around Mercedes-Benz Stadium. Just type in Mercedes-Benz, click Mercedes-Benz Stadium, and it zooms to Mercedes-Benz Stadium. Now then, when setting up the spatial parameter of your query, you've got many different ways to define the road segments. You can combine the methods, like you can search by name, you can search by geographic region. Young lady in the back, remember we were talking about using counties as our geographic search method. We can use segment codes. Remember, we had those unique IDs for every single segment in the database. We can use these map selection tools, and we can, I'll talk about this, we can use a saved segment set that we've done all the work once before, we saved it, and we can use it over and over again, all right? But I'm gonna start with road segment. We've largely walked through how to use the road name method, right? You just type in, oh, I want I-75, and it lists all the options for I-75. You click, I always click the first one because it captures all of them. You might have to go through the list to get some missing pieces, but when using the road name option, it's gonna bring in both directions, right? So you can bring in one direction at a time if you want, and then you remember how we did the partial, right? If you just want a piece of it, you go over to partial. If the road's running north-south, this drop-down list goes from the south up to the north. So if you want to cut things off, let's say my cheat trick is exit 205. I want it to go from exit 205 up to exit 212. So I'm going to just come in here, exit 205. Boom, it cuts off everything to the south. And then, what did I say? I'll just say exit 216. Just look for 216. And then it cuts everything to the north. So that's using road name. It's kind of clunky, but it's if you know the corridor or corridors that you want to search, it might become easy for you to use. So let's set that aside. Now, if we want to use some standardized geographies to select our roads, let me collapse this, turn it visibly off for right now. Yeah.
Can you zoom in back to the corridor? It looks like the southernmost portion, and I've had that issue where it's kind of like, let's say if you have northbound and southbound, there's like an overlap, at least on my end.
Yeah, for this one, it looked like you only had northbound selected.
Oh, okay.
If you go
Yeah, I actually deleted the southbound when I.
Yeah, if you select southbound too, like the check mark on southbound.
Yeah, you'll.
Why does it do that?
It's just the way in which the naming convention is associated with that road segment. So to deal with that, just single click over the road segment that you don't want and remove it.
Yeah, is that faster way? Because sometimes you have such a long corridor, you have to manually.
Yeah, it's a pain when you're using road name. All right, so let's not use road name. Let's do it a different way. Let's say, okay, this is I-75, right? So if we want to, I'm going to put this back in because I hate that pop-up. If we want I-75 for just that area, I'm going to skip over to the map selection tools. I don't need to put a region in because I'm going to digitize on screen. Under road classes, this is like an functional classification, but not. Think of it though as a pseudo functional classification code. So one is interstates. And then what you're going to do is use one of these tools to draw a polygon, a square, or a circle to select the interstates that you want to run your analysis on. So I'm going to use a polygon. You come in here and you digitize a polygon. Finish your polygon, and it's going to select those roads. Now notice it's magenta. That's because it's just cached in your browser right now. Because you may not, oh, it overlapped a little bit down here. I don't want these two segments. So you could come in and using these tools, you say, oh, I don't want those segments. So to pull those segments out of your analysis, and go, oh man, I didn't get that segment, so I want that one out as well. Oh, yeah, I don't want that one either. You're dealing with TS segments, right? So there's a lot of spatial fidelity with that approach. And then once you've selected those, once you've determined that those are the road segments you want in your analysis, click Add Segments, and they'll be added, just like that. Okay? If you want a broad range of, maybe you want a whole group of roads, come in here and, hell, grab all of them. But, let's go out, grab all these roads. You just draw a rectangle around them. I don't care. I just want a regional kind of analysis or a trend map for all the roads within that rectangle. Let's go out and grab them. That's a lot of TS segments that I just freaking drew a box around. All right. Now then, why do I not see them? It's finished. it found 71,699 TS segments. A browser's cache can only handle so much. So we limit what we throw to the browser from a cached visualization perspective to 7,000 segments. Now then, when you hit add, it's going to add all 71,000 to your analysis. You're just not going to see it when setting up the query. So any more than 7,000 segments that you have selected using this method or other methods, they're just not going to show up in the browser. Yes.
So if somebody is not part of my org domain and I wanted to share the corridor I built and did the show segment ID and copied it, does that mean they won't be able to replicate the same thing?
Yeah, they would, but there's a better method to do that. And I'll share that with you in a minute. So I am not going to execute that. I'm going to come in here just for demonstration purposes and do that.
Put a circle within there.
Yeah, I'm not sure. Clear that out. I'll just. All right, I'll just add those. So this is a nonsensical sort of method for selecting roads. Let's go back to region. So if we want to use standardized geographies to define what roads that we analyze on a regular basis, we could come in here and say, you know what? I want, in Georgia, I want Fulton County. What's a neighboring county? Oh, you know what? I don't want Fulton because that's going to be big. Is there a small county that you guys could think of in Georgia? Like rural?
Raven.
Great, G.
R. Raven.
Yes.
Raven?
Wayne County.
Oh, Raven.
Oh, Raven. I'm sorry.
R-A-B. It's Raven.
Raven, yeah, but under equipment.
And then do you know a county next to it?
Stevens.
Stephen? All right, so let's go up to Stevens. All right, so those are two counties that are adjacent to one another that are fairly rural. And you could define what classes you want. Maybe you want, you know, let's just say all of them. Let's see what happens here. My guess is that if they're rural, yeah. So it's modest, right? Not a whole lot of roads, but we use geographies to define those. Let's try something else now. We want all of Georgia. Now then, somebody give me a zip code within Fulton County, here in this county. What's 30308? All right. All classes. So we can select by geography, two different geographies, standardized geographies, county or zip code. So this is our zip code, and we've added that. So look at this. We got all these roads, and we're gonna run this nonsense spatial kind of PDA analysis on. If we had some segment codes, to your point, we could dump those in here and add them. But we've covered how to set up the spatial parameter using road name, geographic region, or map. Now then, I have all of these roads using all these different methods that I've set up. Rick, I want to run this and I want to use these roads over and over and over again. How do I do that? All right. Down in the lower right, in that grouping of roads, click Save as Segment Set. Type in the name of the segment set of all of those roads, g.nonsense. click this button. This is how you get to share this segment set with everybody in GDOT. Allow users within my agency to use this segment set. You hit save. Now then, boop. I'm going to remove all of that. Now you guys refresh your browser and you can open Trim Map, go to saved, the Save tab, and you should see GDOT nonsense. To come up, if you're signed in with your GDOT email address, or no, wait, oh no, it's not going to. That's not going to work for you. Yeah, I'm sorry. I'm thinking I'm working with your same.
But how come it did for the? Oh, because before you shared it with the ad.
Yeah, so that was dashboards. If you were to save your segment set, it would be saved as at dot.ga.gov. If you click that option to share with the rest of the community, everybody else is going to be able to see that. Now, I'm only seeing stuff that's shared with me or my own, but that's how you share it, okay? And make it available to others.
But they can't edit it at all.
No. Are there any questions about how setting up the spatial parameters of a query? I'm actually kind of curious with ClearGuide. Is it pretty standard methodologies, similar methodologies for defining what road segments you want to run your analysis on?
Yes, with the drawing tool, for sure. And honestly, the reason I use it is because it automatically does these TS segments. So I think traditionally, when I've used RITIS, I've done the TMC. But now that I know that TS segments work.
I do think ClearGuide has a way in there where you can do start at A, end at B, and it does everything.
The routing. That is coming for you guys in the next quarter. See, in Q3 of next year, we're rolling that out for you, the route selection. So, what's that?
It's going to be part of our license.
Yeah, no, I mean, you're paying for TS data. We just had to implement the logic.
The route thing, British support told me that the reason why it's already available, I guess, for some other states, but we were not getting it.
So it's, okay, the discussion over here is about being able to use a methodology a route-based selection methodology for defining the spatial parameters of your query. And what they're talking about, I have access to XD data. What they're talking about is this. So I'm going to change my data source to XD. Do you see what happened when I changed from TS to XD? There's one more tab that shows up. Watch carefully. Route. Now watch what you can do with the route selection, which is coming to you Q3 of this year. I'm going to come up here into Virginia. I like the route selection tool. I'm surprised we hadn't implemented it a long time ago, but part of the issue is that, yes, there's an API that has to be specific to here's base map in order to create that route. INRIX provides that API for their base map kind of out of the box, so it was easy to implement. But this is how it works. You click the start your segment by clicking here. You zoom in and you hover your mouse over whatever, northbound, southbound, or whatever. You click once, say, okay, I want to begin my route right there. You know you're going in the right direction. Okay, that's great. Now I want to come up and I want to come down this road. So it's going to use routing logic to turn down that road. And then, so, okay, well, I want it to come back to here, go down that road. Now, this is super useful. Why? Like, why would you want to do a route selection, meandering definition like this, as opposed to, okay, just I-75 or US 41?
Compare the travel time on 3 parallel routes.
Or, like when you're in an urban area like Atlanta, people are commuting using a whole boatload of different corridors. They're not sticking to US 41 or Georgia 400 or whatever, right? They're taking a meandering route to get to work and away from work. And if you want to run performance measure analysis on these commuting pattern routes and corridors, that's how you do it. So you've added this route, maybe this is the route you want to take. So that's going in one direction. And ideally you can add the reverse direction, and it adds that. And now you can run your trend map. But typically, when you're using the route-based selection, it's for the congestion scan. That's kind of a linear roadway diagram analysis, or I suppose you can use it for trend map. But yeah, that's what they're talking about is in ClearGuide, they've hooked in to here's routing engine early on. And we're late to the game to hook into that routing engine because there's licensing fees associated with that. We had to work through that, but hang tight, it's coming. Route selection methodology is coming. All right, so next, I'm going to go ahead and delete this, add in my nonsense roads. Oh no, I got to go back to TS. It's actually nice that I don't have a whole boatload of saved segment sets. See how easy that was? So that's the thing. It can be a pain in the rear to set up the spatial parameters for the corridors that you want to analyze. Just remember to save your segment sets, save that spatial setup so you can do it again, because you're likely going to want to do it again, run analysis again on the same road segments. Now that you've set the spatial parameter for your query, everything else is pretty self-explanatory. I think this is kind of an interesting feature that not a lot of folks kind of focus or kind of tune in on, is that, let's say I want to do an analysis on all Tuesdays for the last 6 weeks. You come in here and say, okay, well, that's the range from April 7th to May 28th, but I just want to look at Tuesdays. All right, just look at Tuesdays. And then, well, maybe I want to look at all the Tuesdays for, the first half of the year. So I come up here and go January through April, and create a single time period for each range, 4 months, just Tuesdays. Now I'm looking at every Tuesday. This doesn't make much sense, but anyway, you do things like that, or say, hey, I want to average out all of the Tuesdays for the first half of the year. So January through April, or for the first 4 months, January through April, I want to create a time period for each month, or I want to create a single time period. So this is a single time period for all Tuesdays within the first 4 months. But now I don't think I'm going to be able to do this because, oh yeah, I guess it did.
Every month.
So now it's going to do a Tuesday for January, all Tuesdays in February, all Tuesdays in March. So you can get really crazy, right? But here's the deal. When you run an analysis, generally you're going to be doing some comparative analysis. You're not going to look at just one day. You're going to look at a day relative to the same day the previous week, or the same day last year, or 1 month or 3 months compared to 1 month or 3 months the previous year. You always want a baseline, or you want to, what's the performance looking like over time? So these tools allow you to basically create any number of timelines that you want to analyze to compare and contrast against over time. Sometimes you just want to look at the Tuesdays or the Wednesdays or midweek relative to all midweek for the same period last year to kind of gauge how things are changing over time. Or maybe you're looking at a special event or a severe weather event. We'll look at that severe weather event on that day and we'll compare it to the same day the week before and the same day the week after to kind of compare and contrast the impact that that severe weather event had on the local network. You have up to 7 time periods that you can analyze. That's it. So we have here. Let's try this. Let's try all Wednesdays. It's going to see it barked at me. A maximum of 7 time periods are allowed. So it added 4 the Wednesdays because I had room. Wait a minute, that's more than 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it added it, but So I guess it gives you the chance to just delete 3 of them, and you choose which ones you want to delete. Remember to always put a title on a report and for easy search, and you don't click run. I don't want you guys hammering the system right now. But in our use case, so we're going to take a look at some of the analysis. I want to show you how some of these data visualizations look. We just went through setting up a query. Is every tool within Probe Data Analytics, is it different in setting up a query? Am I going to have to explain how to set up a query also now in the congestion scan and the bottleneck tool? No, remember I said it's all the same. It's basically the same. You set the spatial parameter and the time, the temporal parameter. All the tools are set up the same from that perspective. There's some variation, like the congestion scan, the temporal, or the timeline. This guy, the corridor time comparison, and the corridor speed bins. Those are linear roadway diagram data visualizations. So they only expect a single roadway. So you can't throw in a bunch of roads because it doesn't know what to do with a bunch of roads because it's just a roadway diagram. If you guys have not opened the reports that I pre-ran for you, let's go ahead and do that. Go back to my training page. Go ahead and open every single one of these reports so that we can explore these together, okay? The trend map. Click that guy. Let's take a look at that trend map that I ran for you and for our analysis. I'm going to kind of walk through how I built out this executive report. It's beautiful, isn't it? You guys like that? So I took one of our report templates. Matt's not here, so I could tell you how I did this. Matt poo-pooed me when I did this. I took one of our report templates, a PDF of it, or maybe it was a PNG. I took it from PowerPoint, I exported it to PDF, and I took the results of, got a snapshot of my trend map, the results of my UDC analysis from game day versus the same Tuesday before and Tuesday after, and then my performance summary for game day versus the Tuesday before and Tuesday after. And yeah, that's reflected here. So the Tuesday before, Tuesday after. So that's one report in the bottom right, 2 reports for the user delay cost, because you have to do it for, well, maybe I did just 1 report. Anyway, there's like 3 or 4 reports in PDA that I ran. I uploaded them to ChatGPT with my report template, and I prompted the crap out of the thing, and it generated this report. It's like crazy, right?
Did you put in the images as well? Like
No,
and all that?
no, it plopped all the images in itself. The only thing that I provided is so the trend map is the trend map, and so you can export from your trend map, your analysis. So let's go ahead and open the trend map from game day of last year. First thing I want to, this is what it's going to look like for you guys. Default performance measure is going to be speed. First thing I want you to do is change the orientation to side by side. The center map is All-Star Game last year. The map on the left is the Tuesday before. The map on the right is the Tuesday after. Change your performance measure to comparative speed. You can zoom in a little bit. Now then, I found this super interesting that at 12 a.m., it was a total mess down by Truist Stadium. I don't know why, but.
So you leave your thresholds the same?
What's that?
The thresholds?
Yeah, I'll walk through. You can configure that. So by default, it's gonna map the values of performance measure, or KPI is going to be speed, but you have all sorts of different ways to look at this. Maybe you just want to look at the weather. Weather? What do you mean weather, Rick? Melvin, this is where it gets really cool. You ready? You ready? Here we go. Remember, the trend map is an animation, averaged performance measures over a 24-hour period from 12 a.m. all the way to 12 p.m. I don't know if there's any weather that occurred, but we're gonna find out really quick.
Hey, teach them.
Weather radar would show up. I apologize because I didn't look to see if there's going to be any weather here, but it looks like there is no weather. But any of these performance measures give you kind of the indication of what was going on across the network at any moment in time. You can animate this. I love the animation. Each one of these segments you can click on, and while it's animating, it'll give you insights relative to the other dates that you've analyzed. You can change whatever the performance measure is. Check this out. I'm going to get rid of the pop-up. I'm going to go back to, travel time index is a good one. This legend is configurable. So if you want to see on game day how things unfolded, in excess of let's say a travel time index of 2.0, which is awful, right? You could play around with this and say, oh, you know what? I want anything above 200% of normal. I want it to be all magenta, which I like to do sometimes. And then I'll change all of these to just, I don't care about those visually. So I'm going to change them to white. It's my way of trying to create transparency and then go back to play. And it really kind of stands out now where the travel time index was highly variable or way above normal on game day compared to the Tuesday after and the Tuesday before. And you could click and hold and play that. You can, oh, you know what? I forgot to turn the weather radar on. Maybe there is some, there was some weather. Melvin, now you can get excited. So the Tuesday after looks like you have to pause and wait a little bit for that next rad weather to like come in. Where the hell was that? There. Oh, there's some weather. Oh, and game day, there's some weather as well. Other display options, you could turn different days on and off. Down below, show percent of readings. This is kind of interesting if you want to look at, observations of speeds for these road segments throughout the day. Kind of cool graph. Some of the reports you can take in their native form. You can open them up as performance charts or other tools. You could save your results. I mentioned this earlier, right? Every report can be exported. You can save it out as an XML file because there's some data visualizations here. You can save it out as an image. That's what I did for my MLB report, my All-Star report. You could create an animated GIF or an MP4 because it's an animation, right? All right, I'm going to show you a little trick. You see that little share button right there? Go ahead and click on that. The trend map is the only tool in Probe Data Analytics where the output report has the function to share it with anyone, regardless of whether or not they have RITIS credentials. And the way to do that is to click that share button. And it's basically prompting you to create some embed code. And embed code is just bit twiddler kind of nomenclature for a long URL that has a header and a footer that you can then dump into a bigger HTML file on a website. Not exactly. But the idea is once you create the embed code, you could copy it and you could do things like this. What's GDOT? What's you guys? What's you guys' website?
Just like their homepage?
Yeah.
Yeah, I think GDOT.dot.
Is it g.dot.gov?
Yeah, that's like that. This one's on the network.
DOT.ga. All right, so
Right, that's like a
You could take that embed code if you're so inclined, and you could come down here and say, oh, you know what? I'm going to don't tell your webmaster that I just junked up your website, but I just embedded that web code into GDOT's website, and look, it kind of looks like the trend map is loading, right? That's because it is. That trend map is spinning up and it's loading inside of the GDOT website. And once it's done loading, it's going to give me the same sort of visuals and kind of tools that were at my disposal when playing around with the trend map with travel time index before I went in and monkeyed with GDOT's website. Now, where did that go?
I was like, I don't know it, but like, I had a license for it.
Now then, here's another trick. You guys ready? Click that embed code. So go to share, click create embed code for that trend map. Share, create embed code. After it spins, copy the embed code with that little button right there. Open a new tab. In the URL bar, hit Control V. All right. Watch carefully. At the end of my URL, get rid of everything up to the double quote at the end. Go to the head of that long URL from your iframe and select everything in front of the URL up to that double quote. Delete it. No, delete the double quote and then hit enter. That's my trend map. And I didn't log into RITIS. So that's kind of a fun way to share a trend map with anyone. Because let's face it, we got some heavy hitters like Justin and Sam. Sam was here in the room. They're senior leadership. They know how to use the tools, but some senior leaders aren't as savvy as Justin and Sam. And you might want to just tell them a story about what happened around the ball game. And you just send them that URL and go, hit the play button, Justin, and it'll tell you the story.
He doesn't mean I'm over 65.
So that's kind of a fun, kind of hidden. Actually, I haven't done this before. Yeah, it preserves the configured, the modified legend that I created. I'm not sure why it's still doing the readings here, but. And then in the meantime, on GDOT's website, I've got my trend map that's been embedded. Man, webmaster's gonna be pissed at me. No, I'm just teasing. That's just cached. It's a fun thing to do, though. All right, so that's a trend map. We've walked through how to set up basically a basic query for probe data analytics for any of the tools. You've got those spatial and temporal parameters. Once that's set, you run your analysis and you have access to all these different data visualizations. We're gonna, where are we in the agenda?
Oh, we skipped our break, but break was 2 to 2:30.
Break just ended.
And then trip analytics, 2:30 to 3:45.
Yeah. Break 30 minutes over, my bad.
All right.
Right, where is it?
I was thinking of meeting for you, Pete. Thinking of meeting for Pete. God forbid.
All right. This is what we're going to do. I want to, again, lots of different tools within probe data analytics. Many of you have explored most of these, but we explored the trend map in some detail, how to set up a query, how to explore and interpret and use the data visualization. I think the trend map is super useful for doing any sort of before and after action analysis, whether it's a collision, severe weather event. In this case, we're talking about the MLB game, or All-Star game, that does have some clear patterns of, event impact. I'm going to reset this so it's. But there's a couple of other reports that we used for this MLB All-Star report, executive report, that I wanted to run through with you. One of them was a user delay cost. Now, the user delay cost analysis is crazy useful if you want to tell the story of what the dollar cost impact of an event was, or whether that event is a World Cup game and how it impacted things, or in this case, I ran my analysis on the All-Star game. Sometimes leadership, executives, and legislators, they don't understand travel time reliability or percent congestion. You know what makes sense to them? Dollars. So when you can run analysis and quantify the impact that the event had in a US dollars perspective, that's important, right? That tells a story that I think resonates with a certain community. So in our case, I ran, to support this MLB All-Star Game report. I had two numbers here. I had the vehicle hours of delay, as well as the percent, the cost of delay for game day, and what the difference was as compared to the baseline. Well, where did I get that? I just ran a user delay cost analysis for the 8th through the 22nd of July. When you run a user delay cost analysis, you can only do it for a range of dates. And honestly, I only wanted to capture the Tuesday before the game day and the Tuesday after, so I could grab an average relative to game day itself. So here we are. This is the Tuesday before at $589,000. This is game day, $602,000, and then the Tuesday after, $369,000. So I think, in my analysis, I took the average between the Tuesday before and the Tuesday after, and I did some math to come up with the fact that, game day impact was plus $123,000. It costs that much more in terms of vehicle hours delay from a dollars perspective, that much more on the All-Star game. That equated to 2,749 hours of delay for vehicles. So this component, or that aspect of this report, was purely derived from just running a user delay cost analysis. You could do delay costs In here is also vehicle hours of delay. So you just change the drop down. You have this report. Did you open it? Yeah. So you can walk through this yourself, do the math yourself. You got delay per vehicle mile traveled. So all sorts. You could split out passenger vehicle versus freight truck, which is useful.
Quick question.
Uh-huh.
You said that you can only run this for a range.
Mm-hmm.
So
No more than 1 year. Sorry to interrupt. So 365 days is the max range that you can run a UDC for.
when you're setting your time parameters, are you able to filter it out like on the other one where it's like a specific day of the week, it's just a flat range?
Yep. Yeah, because it creates this matrix, right? And once you have the matrix, you just, what did I say? Every report can be exported. So for using ChatGPT, I just said, hey, one of the prompts was in the UDC table that I uploaded, take the average of the Tuesday before and the Tuesday after, do the math, give me the vehicle hours of delay and the dollar cost, and do the difference and symbolize it in red because it's more, or symbolize it in green because it's less. And yeah, I literally, generating this report would have taken me probably 2 or 3 hours. Just doing it manually, like up to a couple of months ago, I'd have to open every single report. I'd have to manually do the math with Excel and then dump the values into the report template. I mean, the report templates are great, but I'm sharing with you, there's some cool things you can do out there if you're interested. Now then, travel time impact. Where did I get that? Well, travel time impact is a reliability measure, right? The performance summary tool allows you to generate pretty basic summary level characteristics or performance measures for the roads that you're interested in analyzing. So in the trend map, remember I selected the roads around Truist Park. I just used the same roadway segments. There's 458 TMC segments. I ran it for the 8th, the 15th, and the 22nd. You see each of those tabs at the top? And the results, you have, I should sit down and do this. The results are a column for speed. And speed is broken down. It's been averaged out. We just looked at Tuesdays in this case. 29.5 miles per hour for weekdays. There are no weekends in Tuesdays. So it's 29.5. You got buffer time index, buffer index, planning time index. One of the measures is travel time and travel time index. The travel time index was 1.21 on game day. What does that mean? What's a travel time index of 1.21 mean? You guys are smart ones. I'm not a traffic engineer. Relative. What it means is that it's 21% longer period of time to navigate all those roads in my analysis than normal. So 1.21 travel time index means it's like 100. It's like 21% greater than the norm. So when you look at July, like the Tuesday after, travel time index is 1.17. There's recurrent traffic in that area, but on game day, it went up, right? It went up by, now that's planning time, travel Travel time index, where are we? So let me just kind of see if I can get that. Okay, 1.46, 1.45, game day 1.53. It's marginal, but when you're looking at an index value, you look at the difference, you know, it's marginal, but it's still 4% increase. All right, this is just
saying it out loud. It is as compared to your 50th percentile, right? So your average travel time. So like if you are, it normally takes you 10 minutes, it took you 12 minutes to get there, then that's 1.2, right? So the idea is that this is really helpful when you're looking at interstates plus arterials plus a neighborhood street, that all the speed limits are entirely different. This jams that all in together, so that way you can have a single number. So like especially on SIGOPS routes, right, where you got some that are 25 miles per hour and some that are 45 miles per hour and everything in between. Like on your maps, if you change it to TTI as compared to speed, then everything is gonna have the same.
It's gonna be normalized.
Right?
Yeah.
So like that's a way that you can make sure that you're not accidentally sending the wrong message to people. Where it's like someone might be going 25 miles per hour, but that's the speed limit. That's fantastic. Congratulations. But if you had that as showing speed only, it might show as red, which would be.
Yeah. So back at the trend map, you know, we go back over to the trend map. If you want to normalize things out, use that approach. Just change the performance measure to travel time index, and now, when you're looking at things, it's giving you the index value. And on game day, oh, right. It's like, oh, it's a mess in there. And this intersection is a mess in general. That's what I noticed. All right, so that kind of explains how I came up with this report. Just to illustrate, remember I pointed in PDA. We're going to take a break here in a minute. Remember I pointed in PDA to report templates? I'm going to show you what I started with. Click report, click the templates, go to corridor performance report. There's several curated corridor performance reports. One of them is the Mass DOT. If you click that one, it should download the PowerPoint file. Maybe I didn't use that one, sorry. I used one of these. And I just used it as I just used it as a template. And I said, okay, this is the one I want to use as my template, and just dump in the values accordingly. There's all sorts of cool different templates that you can use. So I encourage you, if you have to do regular reporting, go in, explore what templates are available. Notice that we have templates for all sorts of different use cases, whether it's corridor performance reports, whether it's work zones. Come on. Project assessment reports, top bottleneck reports. These are fun. You guys don't do any of this, but there's a whole boatload of different holiday travel guides. So if you have a media group, you guys are authors to several regular holiday. Yeah.
Yeah, GDOT helped build those things.
Yeah, so you contributed to several of these. And so state agencies all over the country, I'm trying to get Texas DOT right now. There's a woman out of Texas DOT that, every holiday, man, she's cranking through and doing the holiday forecasting with some of these templates. And she's done some cool stuff, but she posts all of her holiday travel guides to TxDOT's social media sites. And she gets really good followership and feedback when she's posting those. Her next activity is to actually measure what she predicted, you know, because your prediction is based off your surrogate from the year before, right? And so you kind of use that as your guide for what you integrate into the report. So let's open up one of these, 4th of July. 4th of July is coming up. And this is actually a PDF, but we have the PowerPoint template for this one. And all of these measures are derived from performing some analysis in PDA. Like, all right, well, for Atlanta interstates, right? What are you going to do? You'll probably run a performance summary, right? Or maybe a performance chart. And you select all the interstates around Atlanta. And you go, well, on Friday it's going to look like this. Congestion's going to start at this time, and limit travel time or limit travel on, during this range. And then on Saturday it's going to look like this. Whatever, right? You're running analysis, but then you're creating these easy to read, easy to consume reports.
Would you mind going back to the templates page? And scroll down just a bit further.
To what? Whose?
Keep going down. Just keep going down. So for everybody in the room, and for our interns in the room, these are built for you. If you don't know anything about RITIS, which hopefully you know a little bit more by the end of the day, this is built for you. So this tells you all the thoughts that go into this, how to set up a query. It is painstakingly detailed.
Yeah.
And it gives you nice little pictures all along the way. These are fantastic ways to get introduced, to feel comfortable with what's happening. So for every single one of those templates that Rick was showing off on the previous page, they're in there. And I think the other thing too, just to call out with these templates and all the tools that you use to go in, is they were specifically built with the assumption that you do not have a graphics design background,
yeah.
B, have any graphics design software, and are at least familiar with PowerPoint, Excel, and maybe sort of kind of RITIS. And the maybe sort of kind of RITIS is that you have an account and can log in.
Yeah.
So like, I don't mean this in a derogatory way in the slightest bit. It is meant as like
baseline,
here,
yeah.
so that we can get you dangerous and that you can do this. And like Rick said, like the first one you do is probably going to take a little bit longer, but once you've done maybe 3 or 4 of these and you have that process down, it's like
it becomes more
90-minute type activity.
More efficient, yeah.
So
yeah, it's a really wonderful resource. All right, let's take a break because we're running a little bit behind. Actually, hold on real quick.
Yeah.
All right. Congestion scan. We have not looked at a congestion scan, but I want to walk you through some features of the congestion scan before we take a break. I'm sorry. The congestion scan is one of like a couple, 3 or 4 tools that generate a linear roadway diagram representation of performance measures in a form of data visualization. And what I mean by that is that the results look like this, and that you have the roadway diagram that you, oh my God, I did all of I-75 for this analysis. So this is a linear roadway diagram representation of all of I-75 through the state of Georgia. This is northbound side on the right. This is the southbound side on the left. These are individual days. Remember what I said about, no, I maybe only mentioned this yesterday. Notice how I have all of these incidents mapped on my congestion scan? That's because I ran daily analysis. If you were to do a weekly or multi-day or monthly analysis, you're not going to see any of your events on here. But when you can overlay your events on your congestion scan, it tells a pretty compelling story. Just like other Pro Data Analytics data visualizations, you could change your performance measure or metric to be, something different. I'm gonna look at comparative speed. We're zoomed way out because we're looking at the whole state of Georgia. If we wanted to, using your scroll wheel, you could zoom in on a particular window of time. If I wanted to focus my attention, let's say I just wanted to look at September 26th and 27th, I'm going to turn off, under my display options, I'm going to turn off the other 2 days. I think by default now, precipitation pattern is turned on. Melvin, check that out, dude. Do you see what I'm seeing? All right. September 27th, 2024, northbound and southbound. September 26th, northbound and southbound. What's different between those 2 days? Do you see like some hash pattern on there? Oh, man.
Okay.
That hash pattern, this is for Melvin. I like doing stuff just for Melvin. That hash pattern, check this out. That is measured precipitation that was collected throughout the entire day, every 2 minutes. So when you hover over the comparative speed measure in that kind of heat map, if you will, it's also giving you a pop-up of the type of precipitation, the rate for that moment in time along the corridor. And if you move your cursor down, you can see that the precipitation rate is changing. Man, it was really raining that day. Anybody remember what happened on September 26th and 27th of 2024? Yeah, that was Helene. So I knew I'd capture some precipitation if I hit Hurricane Helene along I-495. Here you had a collision. That's really cool, right? I see the collision here. It shows a true correlation in congestion patterns relative to that collision. Same thing here. Boop, boop, boop. And then it's like upstream. It's fun to look at patterns in a congestion scan. Now then, what I think is really cool, you know how we normally think of the NEXRAD weather radar as it's passing over the country. It's geographically bound, right? It's like makes sense to us because it's spatial in nature, and we think, oh man, it's passing over my neighborhood. There's an option in the drop-down for weather. This is the weather radar, but stretched out over a linear diagram. From southern Georgia to northern Georgia, beginning of the day, and you'd see how the rain just kind of, moved through that I-95 where it got really intense later in the afternoon. You had flooding events that were reported by GDOT or the Weather Service. It's a cool data visualization. I've actually taken the results of this analysis and I've map enabled it and animated it. It's super cool to check that out. Something else that just I did this during lunch. My wife was trying to figure out, well, do you know where I could go to find out how much rain we've had the last week? In the Weather Service, they only have a certain number of weather stations. They're usually at airports. And you could go to Weather Underground and there's hyper local measurements for precipitation. But sometimes even Weather Underground doesn't give you localized precip measurements. So I ran an analysis. I just selected some of the major roads near my home over the course of the last week, ran the analysis and go, oh, we had 0.68 inches of rain over the course of this last week. Because it just took that roadway segment that I selected, which is in my neighborhood, and I just ran the math. And it gave me hyper-local summary of precipitation for my neighborhood. So when thinking about precipitation, its impact on the network or a corridor, while we provide you some wonderful tools to kind of explore that and kind of do some of your own investigative work, you can export that and do your own work, right? To kind of figure out how precipitation may have impacted things. Any questions about that? No? All right, take a break, guys. Come back in 15 minutes instead of 30 minutes. And that should be enough to should be enough time for us to look at that trip analytics study.
Another one. Another $5 one. My dad made this one. It's so good. Oh, that's pretty cool. Cut it down. I think it's gonna turn my finger. It's still. It's not safe.
I mean, it's pretty cool anyway. More than I expected.
It's roughly this kind of when I sleep at night.
Sure.
Confirmed it anyway.
Question for you. Have you added any signals to your etiquette? I know. So do you add location for like maybe
Do you see the link for the service? So you got more files?
on SharePoint?
No, I've got like our, well, it's in
So
our
it's
SharePoint.
right, so this is year,
Not, actually, not SharePoint site, sorry, the Teams site.
And-
Which is also SharePoint.
Oh.
But if you open Teams,
everyone would just go on these pairs and just breaking each other off.
go north,
And I can't remember exactly what
shared.
exactly was done to you. I think he had switched your native language on your computer to Chinese.
Switch from English to Chinese and then freeze the screen, do that trick at the same time. So it's moving the mouse, you can't figure it out. That is enough that you're just
I
genuinely
was doing this like once a month, and never know
Right.
how to.
So Justin's and he does this during lunch.
Right, so you
Justin's
gotta
coming
add
back for a
location.
meeting.
I
and
don't
he can't get on
have,
his computer and it's just lost.
okay, so I don't have
And-
that option. Is it a?
and so he's like,
permission
storms
thing
off.
probably done?
And mine the next day is out, and so
Right.
Justin is just decided to log in back and go. So
Yeah, that's why I was trying to look through it as well.
he seals his coffee mug. He seals his coffee mug, and
has decided that
You out?
I am out.
He is
Thank you,
gonna
Rick.
hide
It's been
Hey,
great.
yeah,
I'll
you're
try and stop
welcome.
by if I finish up these meetings a little early.
Email me
Lights hung down.
Okay.
anytime you need anything.
Because I just want to make sure that
Okay,
this has been great, really. Thank you for coming down.
you're welcome. I'm glad you enjoyed it. I'm glad you were here. So thank you. All right. Hey there. Thanks, sir. All right, Justin, have a good one.
They got shenanigans. We just have bogus. They was on floor for realness. Oh, it's upstairs on the fourth floor. I'm thinking we're on the fourth floor. Oh.
Hey, Ray.
You're gonna have to do some serious editing.
So, let me think about this. It's picking up the sound. It's picking up as a. Cause I think it went. If this wasn't green as you, because it can only go so far.
Oh, it's like Bluetooth enabled?
Well, not Bluetooth, but I know that there's like a certain range where it won't work.
Okay. Well, it was green when I was.
Oh, in the restroom, but it's picking up the thing from the camera. So as long as I don't think if we outside the room.
Oh, okay.
Yeah.
All right.
And I'll edit it anyways in CapCut because this is too long. This software I use to record doesn't have pause.
So
I have like almost 6
hours.
Yeah, there's no way we're gonna post that on YouTube. So I'll trim it down to how many, maybe 3 or 4.
Through segments.
Yeah.
Yeah, that makes sense.
Don't worry, I got you.
Thank you.
Yeah.
All right. Well, I'm gonna go ahead and jump in since we've kind of caught up. There's a couple of tools that I've talked about that I was hoping to kind of dive into in more detail, but just showing you and exposing you to how weather and precipitation is exposed in some of these data visualizations and the output tools is important. The last piece of today is focused on a separate set of data and analytics tools called Trip Analytics. And I'm seeing that there's a lot of people that aren't back. So maybe I should wait. Did I say 2:30 start? What time is it? My watch is off. That's weird. Huh. So I don't even know.
Oh, did it work?
What the hell is going on here? Ah, that was weird. It's working now. I did say reconvene at 3, right?
You said 15 minutes, I remember.
So that, okay, I think it was 3. Matthew, thank you for bringing the water. I presume that was you?
No, I brought the croissants.
Okay. Who brought the water? Justin? Who? Trey did?
He's not in right now.
My throat is killing me. And yes, sir.
I was just saying, I know you talk about using CCTV cameras and like local stuff, but does RITIS, do y'all have any of your own stuff that you ever set up, or is it only using pre-existing?
Pre-existing, like whatever a state agency feeds to us, we ingest it and integrate it. Yeah, we're not a data provider. We're not, we're not an ITS device manufacturer. We're just a mobility integration, archive, and analytics platform. Agnostic analytics and archive platform. We try to stay true to that agnostic kind of belief that we don't really care who provides the data, what its source, how it's structured. If the agency uses it and they need it to support their operations and planning, we'll do our best to ingest it. So that's kind of our philosophy. Yeah. All right. So we're pretty much wrapped up with the core RITIS probe data analytics capabilities that I want to share with you today. Kind of follow along activities. Are there any questions about what we've covered or reviewed up to this point? Any comments? All right. Yes, sir.
This might kind of fall into what we just covered. I tried to go back. I was looking for a way to pull up previously created
reports,
performance metrics, so there's a history there.
Yeah.
And for me, when I tried to reload something, I got errors opening reports like from 2025. But I'm guessing this is the only way to direct recreate. So I'm trying to pull up
an old report.
Right. So and I said it didn't work. That one came right up.
Okay.
That was the one. Sorry, I hit one from today. So here's one from last year. I get this error. The application crashed. But that's definitely really cool and helpful because once we, you might export something, grab the image, throw it on a report slide. But if you ever want to look back at it, instead of having to go through and recreate the segments, being able to access the history is definitely nice.
So use the history as the framework for setting up another query.
Yeah, right, yeah.
But just changing the temporal parameters.
Or even say, not to talk about iTerrace again, but
yeah,
iTerrace, you can save a route and name it.
Yep.
And so then I have a shelf and code.
You can do that. Yeah, you must have missed that section. Once you set up and define the road segment or the corridor that you want to run your analysis on, once all the spatial parameters are set up, you click
I already saved this one.
Save as segment set,
Gotcha.
and you give it a name. You could share that with others in AECOM.
Can you edit those segments after the fact, or you have to create a new one? You have to.
I think you have to create a new one. Yeah. All right. Most of you, this is my informal survey. Most of you have used RITIS at some point or another. How many of you learned something new already? Raise your hand. Awesome. All right, here's more important. How many of you learned something new that you think you might apply to your job? Ah, nice. I love it. Love it. Okay, well, that's good news. Now, this last section of the afternoon, we have a short, special 55 minutes left together. We're gonna dive into some analysis that's not relevant to the MLB game, but relevant to some analysis that I did, that I conducted for the World Cup games, if you will. I think you've heard me use this term before when kind of thinking about major events and understanding the impacts that those events had on the network. Sometimes you have to use those as surrogates to what may happen or unfold for future big events, right? You know, we were looking at holiday travel guides. Well, you know, the surrogate for producing the 2026 4th of July travel guide was looking at 2025, 2024, and 2023 4th of July holidays, and maybe doing an average. For World Cup, I had to kind of think about what surrogate event has taken place in Atlanta that might reflect the kind of patterns and behaviors of travelers in and out of this Mercedes-Benz Stadium that's maybe different than a football game, you know, that hosts the Falcons. Falcon fans, they know their routes in and out. They're going to use them all the time. It's a pretty standardized flow, and you guys probably have figured that out. This is what we can expect. One of those surrogate events I felt like could be representative of some of these World Cup matches that are going to be hosted here is the Beyonce concert that took place July 11th, 12th, 13th, and 14th of last year, something like that. July 14th was one of the days that I analyzed. I figured, you know what, concert goers, they're going to be different than football. Falcons fans, they may be coming from all over the place. They're generally regional. Okay, well, the visitors that are going to go to the World Cup match, they could be staying in town, outside in the suburbs. They might be taking public transportation, but if they travel in, they're going to be traveling in from all over the place, and they're not going to know what the hell they're doing other than to follow the Nav app. They might be taking rideshare, but where are they coming from in order for them to get to the downtown core area? And more importantly, what routes are they taking? So with Pro Data Analytics, you can get a temperature or get a footprint sense of how travel, congestion, and traffic is impacting a region in and around the Beyonce game. And then if you look at like bottleneck reports, you can see specifically what bottlenecks, what choke points correlated to the event versus recurrent traffic. But in terms of what roads were taken, that's a whole nother level of an analysis and understanding that requires different data. You, my friends, have access to a very, very unique set of data and analytics called Trip Analytics. Did I include the links to your Trip Analytics reports I did. So going back to the training, this is not MLB All-Star, so I improperly indented this. There's two links to trip analytics. One is ingress route analysis for Beyonce and post-event outbound route analysis. Go ahead and open each of those. They should open up for you. We're going to get to evaluating what those things are in a minute, but I'm going to walk you through really quickly what trip analytics is and how you might use it for this sort of scenario. If you navigate to trips.ritis.org, you're going to log in with the same credentials that you log into RITIS with. It's going to take you to this data availability page. Now, I'm kind of curious, does it give you all these data sets or does it just give you GDOTs?
It starts with Georgia. Yeah.
So NHTS as well. That's cool. So you guys do. So NHTS is kind of fun to play with. All right, so it takes you to, so the first.
Just do a quick shout out since some folks have seen it. If you scroll all the way to the bottom, folks, this was a special request that we made to the Cat Lab.
Oh.
So normally the trip analytics package gets updated on a less frequent basis.
Oh yeah, that's right.
This is the immediate area, and it's on a 48-hour lag as opposed to like a 2-week lag.
Sweet.
So what that means for us is that, like, yes, we can't do it the next day, but a couple days after, we can get in, look at our events, and figure out, did we have any blind spots that we weren't aware of. So
this is
that out. That normally that is.
Thank you, Matt.
A special ask that Inter is able to help us out.
So the cadence will be 2 days.
That was the goal, 48 hours.
48-hour turnaround. Because what you'll notice in your default data set is that it typically takes a month to like backfill and process all the trips that occurred through the state of Georgia. I mean, there's millions and, I mean, not millions, there's like hundreds of millions of trips that occur through the state of Georgia. It's a lot of processing. But to Matt's point, in preparation for World Cup, you guys are going to have about a 48-hour lag. So you'll have a game, you go back and do some after-action route analysis, which I'll show you how to do here momentarily, and give you some clear insights on routes that were taken in and out and for the match. But let's go ahead and set up a query for that Beyonce concert. First thing you want to do not run any analysis, please. I beg you to not run any analysis. I'm going to show you how to set up a query. Once you click your data set, there's a couple of different options. All your work gets for a specific sort of project gets encapsulated into a study area. You could set up one study area and run different scenarios, given different days or different hours. So you always want to start with a new study area, or generally. Once you set up your study area, you're good to go for running different variants within the study area. Now, your study area could be one of a couple of options. You can look at just within the state of Georgia. You can define using a set number of counties. Like, okay, I don't really care about any other county, but like drag a box around those counties and boom, that's gonna be your study area. Or you say, no, I actually would like my study area to be just those states. I don't know how it got Louisiana, but it got Louisiana. Oh, I was hovering over it. You could draw a polygon. I want that to be my study area. All right. Or what I tend to do, because sometimes you've got analysis and you want to understand trips that extend beyond traditional boundaries like the state or a county. In this case, we're probably not going to get people coming from out of the state for a Beyonce concert, but I didn't know. So I just said, you know what? Don't bound the study area. So I just said, you know what? Include all the trips. So what this pink area means is that for all the trips that have ever been taken through the state of Georgia, into, out of the state, through the state, of the data that's been provided to you by INRIX, it has some broad geographic range. So you've got folks that have traveled clear out from Massachusetts and as far west for a single trip, right? A single trip that they started clear out in Big Spring, Texas. So yeah, you could get into Georgia from Big Spring, Texas, I guess within a single trip, but that's going to be a long drive, a long, long drive. A trip by definition with INRIX is, you know, that car turns on, that connected vehicle or freight truck or delivery truck turns on, they hit the gas and go. They can make some stops along the way and continue their trip, but a stop cannot be more than 10 minutes. If the vehicle is stationary for 10 minutes or more, the trip ends, and then a new trip begins. Now then, for freight trucks, INRIX has done some kind of secret magic stirring of the data, and they basically can match freight truck trips. You know, so this trip ended in this truck stop, and it began again based on whatever math. There's a lot of trucks that stop at truck stops, but they figured out how to daisy chain freight truck trips where the stop is more than 10 minutes. So they've gotten pretty good with that. So that's kind of the definition of a trip. And of course, there's, you know, obviously origin and destination polygons that go along with it, but the richness is in the actual trip and the route that the vehicle took, which for a Beyonce concert and understanding how that as a surrogate might impact or indicate what's going on for World Cup games could be super important. All right, so for setting up my study area, I'm going to include the full extent. I don't want to bound it. And the next thing you want to do is say, hey, you know what? How do you want to specify kind of the summary output of the zones that are used for origins and destinations? You can use some predefined geographies that we have here, whether it's a county, zip code. It's a little more dense. Sub-county, TAS. What's that? Sub-county would be like their communities, community geographies. So like in Virginia, there's the city of Fairfax, and then there's the county of Fairfax. So they're jurisdictions that are smaller than a county, basically. It's typically town boundary. They're like towns, townships, but they're smaller than a county, but they're not as small as a zip code. Now these are just going to be used to kind of help aggregate and report out from a data visualization and matrix perspective the results of your analysis. A lot of times I like to use zip codes because that's just a common framework, polygon with zip code that people are familiar with. You can use whatever you want. You can even upload your own geography. So you can say, oh, you know what? I've got a GeoJSON file or a zipped shape file. that represents the geographies that you want to sum up your O's and D's with, you can do that as well. You can upload your own custom geographies. Like for MPOs, a lot of MPOs have their own custom regions that they use for reporting purposes. So we built that in just for them. So we're going to use predefined geographies, zip codes in this case. Hit next. You're going to name your study area. Let's see this. I'm just going to call it my test GDOT. That's your study area. That's all you're doing right there is just setting up the study area. What trips do I want to think about from a bounding box perspective? How do I want to summarize and wrap up the OD matrix and the OD map? There's a zone map that lets you kind of look at the summary of trips from a geography perspective. But then the next step is establishing those filters. Like, what do you want to look at from a trip analysis perspective? Now, you don't have to do trip-based analysis. If you're only interested in doing origins and destinations, you just say, oh, you know what? I don't want to use pathways. But in this case, because we want to understand the routes that were used to get in and out of Mercedes-Benz Stadium, we can maintain the default, which is use pathways and generate routes. Click next. All right, spatial filters. What the heck is this? All right, this is where it gets super juicy. And I gotta be honest with you, I don't use this tool a lot, but what this does is it allows you to set up a geofence of sorts that helps the software define the spatial parameter by which you're filtering trips out. And you have all sorts of combinations and permutations for, and let me actually open my deck. I'm going to open my slide deck so I can show this to you. And that's something I did not put in my training page. Trip path. I'll make this slide deck available to you guys shortly, or before you get back to the training website. I'll make this available to you. But the idea is you create all these combinations and permutations of filtering spatially through a defined geofence what condition you'd like to evaluate. So, do I want to look at trips that started outside my geofenced area and ended? So that's actually the exact scenario that I ran eventually, that I ran, and we'll review the results, is I wanted to know what trips started outside the Mercedes-Benz area, Mercedes-Benz Stadium area, and where folks ended up parking, and they stopped there. But you could do all sorts of other combinations. Like, okay, it started inside this geofence polygon and ended outside, or just passed through, or just the trip was just within. Like, you're just looking at local conditions, like people moving from, interregional sort of patterns of travel, and then any number of combinations. So in my case, when I was setting up the query, I said, I want to look at all trips that you can use predefined geographies, but I drew an area, a polygon. I said I wanted them to start outside and ended inside, started outside, ended inside. And the condition, it's waiting for me to draw a polygon. So what I did is I just went in downtown, turned on my satellite image, and I just drew a polygon around where I thought, parking lots might be. So I just started digitizing this area around the stadium and the arena. I don't know jack about what goes on down here. But this is a polygon. So I just said, I'm going to assume that for a Beyonce concert, people are going to be driving in from all over the place, and they're going to park their cars somewhere in that polygon. And that's the condition. I want to know what route, what trips started outside this polygon, and they stopped in that polygon, right? I could also do something like this, where Matt and I came up with this during lunch break. What if we wanted to look at park and ride scenarios? Okay, and the park and ride scenario is, cars, the ride share picks people up and drops them off somewhere within that polygon. But they come in and they go out. So the condition has to change, right? So the condition instead is, where did I leave off? How did I lose track of where I was? Damn it.
It was start outside, end outside, but they had to go through that polygon.
Yeah, but here it is. It's not in with that grouping. For my study, my analysis, understand the impact of the Beyonce concert, I just looking at drive and park scenarios. Now you can add some additional filters if you want, like some, like maybe you want to analyze how many trips came in through a specific corridor. So you do some sample counts that way and draw some tiny polygons for off-ramps for this particular freeway. You can upload your own geography. So maybe you wanted to count all the possible ingress points into the stadium area and quantify that by each polygon. You could do that. You could upload a shapefile or a GeoJSON file. This case, just drew a polygon around here, and I said, you know what? That's good for me for discussion's sake. And now you have to set up the temporal aspect of the query, right? So now I know I want to do my analysis for a specific day. So I went back in time. You have the data available for you. July 14th to Monday, 2025. I wanted to look at trips into the stadium starting at 4 p.m. and same day, July 14th. And people probably would have finished arriving by about 9 p.m. because I think the concert started at 8. So I said 9 p.m. Hit next. Now you can do dates, you can do months. Kind of general best practice when looking at dates with trip data, start small from a date range, time range perspective, and then expand out from there until you get what you feel is a comfortable statistical representation or sample count of trips that you think is representative of the number of trips that are coming into the area. Generally speaking, you have a couple hundred trips that you capture with your analysis. That's a good indication of the routes that people were taking or the trips people were taking for that time period that you're analyzing. This is a super small window. So I was actually surprised at how many I picked up for coming in from 5 to 9 into Mercedes-Benz Stadium. All right, so I hit next. This data set is segmented from passenger vehicles to freight trucks to delivery trucks. So you can pull out just passenger vehicles. So I ran my analysis just on lightweight vehicles. And then, once you're wrapped up, you click submit, and voila, this is what we get. So it opens up by default. You tell it what you want it to open up by default, and I think most of the time it's going to be an OD matrix. There are 3 data visualizations. All of them sum up to the same number of trips. The OD matrix table has 185 trips. The zone map, if you were to count all the trips that took place in between all of these zip codes, it'd be 185. Okay? And then if you were to count all the route trips and the route analysis, I'm gonna just open that up as route map. Oh, that's not the one I want. 414 Georgia, 414. All right, I'm going to do it this way. Hopefully that's it. And then open. So it's actually not 185, the zone map and the OD matrix has 103 trips. Yeah. All right. I ran other analysis during lunchtime, so my apologies. I'm kind of mixing up my data visualizations and results. So for that Beyonce concert, for that polygon downtown into Mercedes-Benz Stadium, this is a matrix table of origins. Remember we defined zip codes as a way to roll up the OD matrix and the OD zone maps. So this is just giving you a tabular matrix, origins and destinations. Most of the destinations were right downtown, 301, 30313. Total count, 103. If we were to count and summarize up all the O's and D's for this zone map, it would add up to 103. If we look at the route map, there's 103 trips. So you get it? These are just different visualizations of the same data. You got a matrix, a zone map, or the route map. The route map is what is compelling because what it's doing is it found 103 trips. So different routes, different vehicles, statistically significant representation. 103, I think, is pretty interesting and significant for from 5 to 9. I ran my analysis from 5 to 9 on the 14th for the Beyonce concert. It's a pretty interesting and I think statistically significant representation of all the routes that were taken on the night of the concert. This is typically ranked by the number of trips. How it decided to rank these, because every single route was unique. There's no single route that was that a passenger vehicle took that was the same. Now there were several road segments that were used along the way that were consistent with the different routes. But when you look at, it's like, God, the range, like the range of distance that people took to get to downtown is crazy. You could hover your cursor over the map to get, let me just zoom out, to get a sense for, all right, there's 2 trips in this particular segment, represents 2% of all the trips, there's 2 routes, 2 IDs, and they're ranked 67 and 52. And it gives you the labels for those, the road names for those. As you zoom in and hover over this, you're going to get a much bigger hit on the number of trips that used that passed over that road segment. Does that make sense? Like there's 103 trips, but Northside Drive, Northwest, and all the other roads that correspond to that segment, that road was used 10 times to get into the stadium area. The data visualizations, it's fine, right? It gives you, here's the deal. The analytics tool allows you to query the data and pull it out, and it's super insightful, right? I'm like, you're telling me these are the trips that people took, like physically in their cars to get into Mercedes-Benz Stadium on the night of the concert? Yes, this was observed trips. This isn't made up. This isn't modeled. This isn't synthetic. These are observed trips that vehicles took to get to the concert that night. And now you could say, wow, I've got a representative sample that's pretty significant to help me understand what roads might actually be taken to get to a World Cup game, given the same sort of parameters, but how might I look at that in a different way? There's all sorts of details that come along with each route. You can explore all the, every single road segment that was part of that trip, the names, what the average speed was, the length, the travel time, the mean travel time. Like, gee, many Christmas, this guy traveled an hour to get to the concert. People love Beyonce, huh? This one, let's see, where is that one? Like, these guys came in. That's not the same, is it? That looks like a long, there it is. Number 92, their travel time was 1 hour and 3 minutes. This is kind of fun. Like the 95th percentile, you could sort this. See, like, the longest trip was 1 hour and 30 minutes. Like, what are these guys doing? Yeah, like they came in, they're not that far out. They went, oh, we made a wrong turn. And we got to, oh, wait a minute. The nav app sent us in the wrong direction. Like, this is easily 10 miles out of the way with that wrong turn.
Sorry you're trying to car. Maybe they picked up a friend.
Oh, you know what? They could have been picking up their buddy.
At that point, just catch the water again.
That's what they thought about.
That's what it is. But it's like some of the patterns that you see are pretty interesting, right? With this data. Yeah, this is one of those far out. God, 1 hour and 3 minutes. Here's another one. That just took a long time.
You don't do like Ubers.
Well, so one of the comments was, are any of these Uber? Probably not rideshare, because remember, a trip has to stop and be stopped for 10 minutes or more. So Ubers, they're going to drop off and get the hell out of there, right?
It's not cell phone data.
It could be a combination. No, correct. This is CV data, connected vehicle data. There is LBS data that's not, I mean, it's available to you, and there's some caveats to using it that I don't recall. But I know that INRIX is cleaning some of that up to help provide some comparison and contrast and do some of your own scaling, if you will, because LBS data is super rich.
The challenge that they found out, Rick, I think, that INRIX discovered was that since they source from a bunch of different people to come in, that they were getting, on the LBS side, they were getting multiple
Duplicates.
of the same, right? So it's like, this isn't like, so they needed to figure out how to,
Dedupe. You got to deduplicate, because you could be running the same different apps on the same device, and it's picking up your location. And yeah, to that point, INRIX could be collecting from, what's the big one that tracks family members and loved ones? What is it? Life 360, a huge one. Massive amount of trip data comes from that one, and it's all real time. And then you could be running your health app, and it's tracking your location in real time in the background, and all your apps are running location in the background, and they source all of that, but they got to figure out how to deduplicate it. So here's the deal. I'm a map guy, right? I have the results arriving into the Mercedes-Benz Stadium for the night of.
So there's a question over here, and I just wanted to clarify this for people.
Okay.
When we say connected, in this context, when we say connected vehicle, it is not what GDOT says connected vehicle. That is like, what GDOT says connected vehicle, that's capital C, capital V, roadside units, onboard units, very formal connected vehicles. This is, you have a 2022 Honda Accord, and there's a cell phone router somewhere embedded in your vehicle. The reason that you do not pay that cell phone bill is because the data is sold to us.
Well, and it's to help with safety telematics. The manufacturers,
So in that case, it's small c, small v, connected vehicle data. It's all anonymized. They don't know that it's.
Oh yeah, it'd be.
Well, we don't. How about that? We don't know that it's that. It's on screen.
Nobody knows what it is. It's who it is.
There is a very clear difference, and I did want to call that out. This is not.
Thank you, Matt. And that is important. It's just onboard GPS onboard vehicle GPS data sources. Now here's the other thing. A vehicle doesn't have to have an onboard nav system to have a GPS. The manufacturer still has safety telematics that's running in the background to help diagnose some issue that may have occurred in the vehicle at the time of a collision, or maybe as part of a recall, or just because there's no nav system in the car doesn't mean there's no GPS that's keeping track of where that vehicle is. All right? So and it doesn't have to be a new car. It could be, he could be a decade and a half old, because there's consumer-based GPS embedded in vehicles a decade and a half ago.
Do you know about the oldest cars with the model year of the
No idea. No idea. You can ask your manufacturer. All right. So is what I've shown you so far, does that make sense in terms of how to ask the question of what routes were taken to get somewhere or through something. Like from a, just like, how do I set up a query with this data? Now then, any questions about that? It's still the fundamentals, the where and the when, right? Now for myself, I like to monkey around with data outside of our standard data visualizations. So I exported this data, you'll like this, as a GeoJSON file. And I didn't want the study area, but I wanted the routes. And you have the ability to like create one line per route, which we had 103 of. I didn't need to do that. But I chose one line per segment. Segments can be shared by multiple routes, right? Remember we were looking downtown, and right downtown, I can't quite get. So that road segment, or that segment of road, was used by 14 other trips. So when I went to export my data, I said, I just want one segment, but I still want you to capture what trips use that road segment, right? Where they came from and where they went to. So I exported that GeoJSON file. You can export it as a shapefile if you want. There's an option there. For the shapefile, if you're a GIS guy or gal, just remember that it's a zip file of zip files. So you've got, it's packaging up the study area or the spatial filters, because I checked spatial filters. It's zipping up the routes as a shapefile, and then it's zipping up and packaging both of those together. So you kind of have to unpack things if you're using the shapefile off him. In my case, I just created a GeoJSON file, and then Matt, plug your ears. I used ChatGPT to create this app. I said, you know what? I want to see all the routes that were taken during the night of the Beyonce show, and where they were coming from. I want it classified using not a normalized classification, but a equal distribution. I want these colors, and then I want to be able to filter all of these routes and trips by trip count. So each road has the number of trips that that road segment was used, and I want to put it on a slider. So I have this slider down below. As I move to the right, it kind of filters out the road segments that were used by 3 trips or more, 4 trips or more, 5 trips or more, 6 trips or more, 11 trips, so on and so forth. Now, by the time you get to 15 trips getting in, that makes sense, right? You know, everybody's trying to get in. Most of the routes are going to be eventually ending up in that general vicinity. But what's cool, and we talked about this a little bit yesterday with Western, Central, and Eastern SIGOPS folks, is that when you compare the bottleneck ranking report for the Beyonce concert to the temporal comparison map to this map, like you try to do you kind of in a cube format, you analyze all of these patterns, that the arrival into the concert was highly distributed, and where the bottlenecks occurred, highly disruptive. And like from a traffic analysis perspective, I'm not I mean, look at the pattern here. You got people coming from all over the place. Now, departure is going to be a lot more consistent because it's the end of the night. GDOT, you guys define which exits to use out of the downtown area. But in terms of prepping for World Cup, it's kind of a telling signature to what you may be up against. That, people that are coming to watch the game, they could be staying anywhere and a broad range of areas, and that this might be indicative of just the crazy kind of paths and routes and directions from which people are coming to get downtown. Now then, you have access to this analysis. I included it in the training resources page. You take this and do what you wish with it, but I think it's a pretty interesting pretty interesting analysis for just the breadth of options that people are taking to get into the stadium. And can you control that? I'm of the opinion that, Justin, Sam's not here. Maybe some selective DMS messaging to help travelers funnel in a direction that you want could be helpful. We've got these routes out here that are being taken that may not correlate to typical paths into downtown. And you could throw up mobile DMS signage in different locations to really help target directional insights. And just think about this as a way to help improve communicating with the travelers into the World Cup games, right? Because these are the routes. These are the routes that they're probably going to take. That's the conjecture. And it's conjecture based off data. This is data-driven insights. This isn't, again, modeled or assumed or projected. These are observed trips. These people took these routes to get to Beyonce on July 14th, Beyonce concert on July 14th of last year. And I think that's pretty telling. All right. What else? We're done. Now we open up to comments, questions. It sounds like this is good. Most of you are learned something new. Thumbs up. Yeah, Rick, I learned something new, and I'm going to be able to apply it to my work, which I think is cool. What did you guys think? You're young professionals just getting into the industry. What did you think of this stuff?
I think it was a good explanation. I feel like I know how to use a lot of the tools, and I feel like it's pretty easy for new users, especially someone who's got new through, to get an idea of it.
Awesome.
I'll say the same thing. I feel like you really did really scale it. I think well, and then if you didn't get it, I appreciate all the tools and tips with the tutorial side in there where you can go back and review it. So I learned a lot.
Awesome. Even the youth of America and traffic engineering is appreciating what we've done today. I love it. Any thoughts or suggestions that you guys want to share with me privately? Feel free to email me. You've got my email address. Something to put in Matt's ear or Sam and Justin is if you feel like we can maybe benefit from even more exploratory work, deeper dive into some analysis, I'm happy to do a virtual session. It's very different when we come together, right? in person. It's super meaningful, much more impactful when we're here together. We could see, we can interact, we could talk, I could point, and it's so much better. Thank you for your time. It's a big investment by you, but I appreciate it. But if you feel like we can dive into something with more depth, talk to Matt, Sam, and Justin and say, hey, you know what? Maybe we should do another session with Rick or one of his colleagues on this topic. And we'd be happy to do it. We're at your service. We're kind of an extension to the consulting team for GDOT in general. So we're happy to do that for you. You had a question, ma'am.
Yes, so I noticed you have the whole camera set up. Will the recording of this be available to us?
So yes, can you talk about the recording of today's session?
Yeah, I think the goal is to post it on ITS Georgia YouTube page as well as Georgia IT YouTube page. So I'll work on the edit and probably post it earlier next week. I don't know about ITS Georgia. That'll be better.
Yeah, but the idea is like each of the sections that we ran through today, each of the groups. Yeah. So I mean, many is a stretch, but you know they're like an hour long. But
If you make today's training a playlist, you could make it a series. of
Yeah.
like videos.
but that way, you know, if you wanted to just come back and rewatch how to set up
Yeah.
the trick piece, you should be able to easily find it. But,
Yeah, good question. Yeah, it was all recorded. Thank you. Thank you, guys. Appreciate you. ITE, Georgia ITE, IT, and ITS Georgia. Yeah. And I'll get your certificates out sometime next week when I feel like it.
Thank you very much.
You're welcome. I'm glad you're here, man.
I enjoyed it.
Good.
Brought a lot of crowd with you today.
What's that?
You brought a lot with you today.
Yeah, that's good. ACOM represented strong.
Yeah, we're the best. Don't let anybody fool you.